Kata nak validate order, student punya ID lah. Okay.
Waalaikumsalam.
Sepatutnya boleh lah. Kita tengok Okay. Assalamualaikum warahmatullahi wabarakatuh. Okay. Everyone, thank you for joining this workshop. So again, we welcome everybody to join this workshop both in face-to-face session. So we have 3 participants actually we have 5. But at the yesterday we were informed that 2 of them are not eligible or they cannot make it for face-to-face session. So we have three participants for face-to-face and the rest will be coming for online session. So again, welcome to INHAT, International Institute for Halal Research and Training of International Islamic University Malaysia. So my name is Muhammad Shirami Abdullah Sani. I'm the coordinator of INHAT Laboratories, IIUM. Okay. So for your information, this workshop is the fifth workshop that we conducted. I think we start since last year, okay, during COVID. So we initiated the workshop online at the first place, and then we will continue with the hybrid this year, okay? Because we know that having an online session will be coming some hurdle or challenges for some of us. So that's why we offer to have a hybrid session. Okay. But what we saw now, people are really keen to have online session. Perhaps they think they have what we call that one challenges instead of in terms of coming to or having some commuting to a certain place lah. Okay. So again, this session actually, if I conduct previously for online session only, we conduct in 2 days, but only 4 hours and 4 hours. But since now we plan to have a hybrid session, so we will conduct the workshop in a 1 day. Okay, so I hope that everybody can um, see the note and also the data set that we are going to use this session. Okay, let me share first. Okay, I already paste in the WhatsApp group. Okay, I already paste in WhatsApp group at the same time already paste to our Google Calendar. Okay, so in this session as well, okay, I also paste the Google Drive for our note and also our we call it data set that being used that are going to be used in this workshop in our messages in our Google Meet. Okay, so I hope that everybody can retrieve all those node and also the data set. Okay, let me show you where is it. So it should be in the Google. Okay, so if you can see here, we have this multivariate data analysis in food 26/07/2022. So we have the node at the bottom here, and then we also have the data set that going to be used in this workshop, which is this one, Excel micro enable workbook. So this indicate you need to install the software of XLSTAT. So I think Sister Alifa already telling us that we need to install the software before we start the session. Okay. So if you have any problem related to the during this session, you can uh, type in the message, or if you want to talk, you can switch on your microphone. Yes. But if everybody can hear my voice, so something happened with the participant laptop. So Sister Alifa, can you hear me? Ah, so if the participant cannot listen or cannot hear what I'm saying, while others can hear it, so meaning that you have problem with your connection, or you might need to restart your laptop, so that we can continue. Okay, beside of that, don't worry, this session will be recorded. So I will upload the recording in the YouTube and provide the YouTube link after the workshop itself. Okay. All right. So Sister Alifa will monitor any message that coming from the participant. So all the data need to be downloaded, or we just retrieve through Google Sheet for analysis. So you need to download the data set first, because if you open it using Google, we call that one, system, the XLSTAT is not being installed. So you need to install the XLSTAT first in your laptop, and then you download the Google Sheet, the one that I share, the Google Excel, and then from there you can do the analysis in your laptop directly. Okay. All right. So if you have any problem, just text there, or okay. Yeah. 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 Download sumo file. Mm-mm. Okay. Because each file will be covering all those topic that we are going to listen, or to be shared, that we are going to share today. Okay. Okay. So the think tank, is it okay? Everybody's okay? Yeah. The face to face one. Okay. Uh, okay. So for those in the face to face, while we sharing the session, I will call Sister Alifa to setting up the power projector as well, so you can see here later. Okay. All right. Okay. So this is the topic that we are going to share today. Yes, this morning until 5 p.m. We try to make us uh, to end it a little bit earlier, because some those who work having a face-to-face session, they might need to go back earlier as well, because we know that we're having problem with the congestion in Malaysia, especially in KL. Yeah, so we try to accommodate all those needs from these participants as well. Okay, so the topic for this session is multivariate data analysis in food studies 5.0. 5.0 means that we have conducted this workshop the fifth time. Okay, so again, my name is Muhammad Shiram bin Abdullah Sani. I'm the coordinator of the laboratories in HAT IIUM. So previously, I worked as the registered chemist for Department of Chemistry Malaysia, Ministry of Science and Technology and Innovation, starting 2006 until 2013, and then I continued my PhD and joined in HAT in 2018 or 17. Okay, kalau nak tu boleh kita pasang elektrik betul, cable. Okay. So this workshop that you are going to learn, the one that we are going to share this morning, we will be using a software, we call it XLSTAT. Okay. And then we will start with how you can install the software for those who just not yet been installing the software. Okay. And then this is our tentative program for today, Motivated Data Analysis in Food Study 5.0. So we start with the installation of XLSTAT, and then we will continue with the part A, which is prerequisite for motivated data analysis. Okay. And then we have the hands-on of the prerequisite. And then the break, we have break. And then we have PCA, or principal component analysis, the hands-on, and then we have cluster analysis, and it's hands-on, and then data discriminant analysis. This one will be starting this evening session. Yeah, and then the hands-on, and then the last topic is about multiple linear regression in food studies, and it's hands-on. And then afterward, we can have Q&A, and we can disperse afterward. Okay, but between each of the part, you can still ask question. We will try to answer your question, and then if you want to compile all your question in the Q&A session as well, also recommended. But I will prefer if you can ask the question before we move to the next part, so that you will not be apa we call that one, having problem or any uncertainties being compiled in your mind until to the end of the session. Okay, so even though the this multivariate data analysis, we are talking about four parts of multivariate analysis. There are lots of multivariate data analysis around the world, but this is the one that I want to introduce to all of you. Okay, so as an introduction, why this workshop being promoted as part of INHAT, we call it workshop session. So each month, INHAT will conduct their own workshop. We have FTIR. Next month, we have GCMS. We also have PCR for DNA testing, so on and so forth. But this topic, multivariate data analysis, we promote this workshop because as the chemist, I receive a lot of requests from other researchers and lecturers, even some from industries. They're asking about this multivariate data analysis. So previously, when I worked with Department of Chemistry Malaysia, Ministry of Science and Technology, mostly I involved with environmental samples, where we try to investigate in Johor Bahru, shoreline, where some cases we have the oil spill happen, tumpahan minyak lah. So this oil spill problem occur where there are some ship that they uh, having some collapse, or sometimes uh, they spill the oil in the Johor shoreline. So in this case, there are a few case of ships. So we try to investigate which ship have been is the responsible or was the responsible what we call that one entity. So we analyze the oil in the ship as well in the sea water, and then we analyze the alkane polyaromatic hydrocarbon, and we proceed with this multivariate data analysis, especially um, discriminant analysis, and we able to find the culprit, and then we bring this culprit to the court case in Malaysia, and they have to pay the government for the spillage cleanup. So having this experience, and then when we join in halal industries and halal realm, most people try to asking about how we can authenticate any samples. So beside of halal as well, some people also they want to identify contaminants in their product in food. So they also can use this multivariate data analysis. And the problem is uh, when we look back at the publication related to food, uh, they are lacking of information on how to do the multivariate data analysis. And if we found there are some multivariate data analysis being used, the problem is it's not properly documented, and we call it the flow of the analysis is not properly described. So that will become a challenges or some challenges to researchers in food to follow. Which step is the best, and how do you want to know whether the data that you have for multivariate data analysis is enough, is considered enough before we carry out the multivariate data analysis. So those challenges will be covered, will be addressed and covered in this workshop. Okay, so this is a part of introduction. And for your information, we are not only talking about food. Multivariate data analysis can be applied to any kind of field, provided that you have multiple variable, more than three and above variable, and then if it is enough for multivariate data, then you can carry out multivariate data analysis. And this is coming like last week, we just uh, published a prediction analysis. My team, we were able to publish a prediction of COVID-19 cases in Malaysia only using a 1 year of our PKP data set. So we use this multiple linear regression to provide the prediction, and it's being published last week. Okay, so that's mean this the one that you learn today is not only applied for food, it can be applied to any kind of field, provided that you have enough data. Okay, so let me proceed to the next session. Okay, installing the XLSTAT software. Okay, so this is the link. If you look back at the note that we share in the Google Drive, yeah, you can open this one and then click the link here, and then you can open the uh, you can open the link of the the XLSTAT software. Okay, so for those who just install, is good. We can proceed. For those who do not install yet, please install the software before we proceed to the first session. Okay. So what you can do after you click the link, you will get this features in the window. So we will have here try now. You can click try SLStat. Yeah. And then from there, you can click SLStat here, try SLStat. Okay. And then choose your installer that suits with your operating system. So if you have a window, you can click on the left side here. If you have the Mac, you can click on the right side, and then you can follow the direction or command post the installation. Okay. Okay. But if you look, sometimes they will require you to fill in some information. So from here, you can choose your preferred operating system and click download. And then you have to take note this XLSTAT software, the one that I share with all of you is the 14-day free trial. So meaning that after 14 days, you might need to purchase. And and then you have to take note as well, if you are using your student's ID card or matrix card, you can get a price as much as $50, meaning that almost 200 ringgit, yeah, that, or 200 plus. Yeah, for 1 year usage. I'm sorry for lecturers and for industries, it can cost us up to 2,000 ringgit. Okay, you can also download with other means, but I will not disclose because we are recording. Yeah, yeah. Mm. Uh, it's okay, no problem, no problem. Kalau tak keluar, okay, no problem. Provided that you can use it. Uh, okay, boleh? Okay. So it is 14-day free trial. Uh, you nak download cara lain, boleh. But I will not disclose because I will upload this one to the YouTube. Okay. Alright. Okay. Kalau dah install, after the installation, you can open your Excel, your normal Excel, and then you can have this tab. We call it XLSTAT. You can click that. Yeah. And then you can get these XLSTAT features lah. Yeah. The one that we are going to do for this workshop is the analyzing data. Sorry, we are going to use preparing data, and then analyzing data, some, and then modeling data with that from this feature of XLSTAT. This will be covered in this session lah, this 1 day session. Okay. So before I start, I would like to recommend, please, all of you, please, what you call that one? Could you please install the software? Yeah, make sure you install the software before we proceed. Yeah. All right. Okay. Okay. Kadang-kadang orang tanya, kenapa nak pakai XLSTAT, kenapa tak pakai SPSS? Okay, the first thing I have to, we call it confess. This is my confession. It's not like IUM confession macam Facebook punya confession tu. Okay, this is my confession, which is during my working experience and my traineeship with the Ministry of Science and MOSTI, I was exposed with the XLSTAT because it is attached to our Microsoft Excel. Yeah, compared to other software, we need to install and then we need to we call it import and export, so on and so forth lah. Yeah? And then I'm not familiar with other software, SPSS, Minitab, Unscrambler. Some of it yes, but not much as this SLSTAT. So that's why I choose the SLSTAT. So I just want to promote this one. It's not the best software, but it is easier for me and then I just promote this one provided that I can explain to all of you. Because from this XLSTAT, as far from my practice and my publication, I'm able to understand what the results mean. So that's why I prefer to use this one. But I think it's not saying that this is the best. You can also use other software as well, provided that you know what the results appear in the other software means, so that you can able to explain. Okay? Yeah, please, Dr. Intan.
Focus here,
Mm.
below language and focus is classic or passing life sciences. So do we need to change or just classic?
I just put kejap
So
Oh, no. We can just simply choose any, actually. Yeah. Okay. But I think Dr. Intan, this one is locked. It's not fully
because
full features. Okay. But it's okay. For those having problem later, I will assist you, especially those having face-to-face with me. I will try to assist you on installation. Okay. But let me proceed with this one first before we have some short break. Okay. So let's talk about why multivariate. Apa maksud multivariate? Okay. So when we talk about multivariate, that indicate you have multi-variable. Ada banyak pemboleh ubah. Yeah. Uh, so that's why we call it multi lah. So bila nak guna the word multivariate? When we need to use the word multivariate. Okay. So when we talk about multivariate, okay, in general, I prefer to use when you have one variable, we call it univariate. Satu variable, one variable. Oh, I'm sorry, if you have some non-Malaysian here, I try to make it bilingual. But if you think that I need to repeat in English, just insist me to do it. Okay, so sekejap, okay, that's why we call it one variable. We call it univariate. If you have two variable, we call it bivariate. Okay, so satu variable, one variable, univariate. Okay, two variables, bivariate. And then when you have more than three and above, three and above variables, we call it multi. Okay, so in this case, if you look at this example, the one that I share with all of you, this is the um, sample which is bovine, daging lembu. Sorry, it's not daging. I think daging lembu. Okay, we call it bovine. So this bovine, I analyze amino acid. So the one that you see here, yang ni amino acid, HYP mean hydroxyproline, HIS meaning that histidine, SER meaning serine, and so on and so forth lah. Okay, sampai yang hujung, at the end of it, MET mean methionine. So these are the amino acids that are commonly found in any animal or even human flesh lah. Okay, so protein. Okay, so from here you can see we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So we have 13 variables. So definitely it falls into multivariate. Yeah. So multi-variables. So when you have multiple variable for one sample and you want to know the relationship among the variables, so that's why we conduct multivariate data analysis lah. So let's see about other eight. Eight here is this eight: bivariate, univariate, and multivariate. So let's see about what about the univariate. This is just like our refreshing the mind that about statistics that we have learned or mathematics that we have learned previously. Okay, so how about univariate? So when you have one variable for one sample, okay, and how to display the result of univariate? Okay, so you can see here we have one sample. This is bovine, lembu punya daging, and then this fish, F meaning fish, and then this is porcine, yang ni khinzir ataupun babi, and then we analyze only hydroxyproline. Satu saja hydroxyproline, one amino acid. Okay, so one sample, one variable. So we can display the results in term of frequency distribution table. Kita buat table, jadual, ya. The porcine, bovine, and fish, what is the concentration range, and then how much the frequency. Okay, frequency meaning that numbers of that amino acid here, in this case hydroxyproline. Okay, we can also display or represent the result in the form of pie chart. Ni zaman-zaman kita sekolah rendah dah belajar pie chart. We learn this from our primary schools. And then we also can convert them into bar chart. Okay, so from this bar chart, we can see porcine here having the highest hydroxyproline, followed by bovine and fish. So this is how we display the results. And from there, we can also conduct some additional statistical tests. We can do the t-test, ANOVA, Man-Whitney U test, Wilcoxon, and so on and so forth. Okay, so provided that if we want to compare the results of one sample with one variable, we can use this test. Okay, so this is for univariate. Okay, another refreshing your mind session is about bivariate. So bivariate mean you have two variables. Bivariate maksud dia ada dua variables lah. Okay. Minta maaf, tulisan tak cantik. Dulu saya nak jadi doktor macam Dr. Intan, tapi sebab tak mampu. So, tapi tulisan boleh pakai. Okay, two variables. So we have here, what are those tests that we can do if we have two variables? We can carry out a Z test. We want to compare this one, for example, we analyze a lot adulteration and then actual one, and then this one is the determined one. We prepare the lot adulteration in palm oil, for example, and then we want to predict the lot adulteration, so we get this result, and we want to compare this and this, so we can carry out a Z test. Okay, we also can conduct a chi-square test to find the relationship between the two variables. It's very small here, I'm sorry here. So we try to find the relationship between hydroxyproline and histidine. Both of these amino acid do they have any relationship? So that's why we carry out chi-square test. And then the good thing is these results coming from XLSTAT as well. So they provide the results and explanation to all of you. For example, okay, to carry out a chi-square test here, the XLSTAT provide the hypothesis, the null hypothesis, which is they say that the hydroxyproline and histidine are independent. They don't have any relationship. And then the XLSTAT also provide the hypothesis alternative, to say that there is a link between hydroxyproline and histidine, meaning that there are a relationship between hydroxyproline and histidine. So this is the one that we are trying to investigate. Do they have the relationship? So from here, they compute the p-value. So the p-value here is 0.236, and then you can see the explanation here as the computed p-value, this one, the computed one, is greater than the significant level stated or set as 0.05, meaning that p less than 0.05 setting, one cannot reject the null hypothesis. So we have to accept this one. Okay, so that indicate one cannot reject the null hypothesis. That indicate hydroxyproline and histidine are independent. They don't have any relationship. So this is the chi-square test that provided by the XLSTAT. This hypothesis null and hypothesis alternative is not I'm not the one who write down. It is the software telling us what are the hypothesis null and hypothesis alternative. If we learn, okay, in my session, I did my degree in USM. When I study this, those statistical analysis, I need to remember or to put in mind what are the hypothesis null and hypothesis alternative. Yeah, but in this software, they provide for us. So at least we don't have to memorize what are the function of the what are the h null and h naught of the chi-square. Okay, so this is why another reason why I choose XLSTAT. I'm sure other software as well provide the similar results or similar features, but this is what I found in this XLSTAT. Okay, and then another test that we can carry out is scatter plot to display the results. Okay, and then you can see hydroxyproline and histidine is plotted. So this one hydroxyproline, and then this one is histidine. Yeah, and then we can develop the R square, coefficient of determination. And then you can see the R square is 0.136. And this is equal to this one. Yeah. So we know that R square that near to 1 indicate they have a strong relationship. Okay. So in this case, it reflect again the chi-square test. They say that hydroxyproline and histidine doesn't have relationship. It's also proven that the R square is very low, which is 0.136. We know that if we have R square, maybe perhaps 0.8 up to 1 is considered strong relationship. So it's proven here. Okay. So this is the bivariate test that we can uh, learn or try to have some memory back in our cerebellum here, in our mind. Can we remember back what we have learned about this test? Okay, but now you are now moving to your masters, your PhD, or even we are lecturers. Now people are going to big data, so on and so forth. So this univariate and bivariate, people are not looking into that more. They are moving to that big data. So that's why multivariate now is in trend. Okay. That's why now when we try to publish papers, even the editors or some of the, we call it reviewers, recommend us to provide the multivariate data analysis result. Okay. So from there, we can find the relationship. Okay. So sampai situ, we move to this slide. And again, why multivariate? Okay. So you need to carry out multivariate data analysis if you have, sorry, this one, three variables and for one sample. Yeah. And then to know the relationship among the variables. Dia macam ni. Tiga dan ke atas lah. Okay. And then what we can get from this multivariate, so this is an example of the similar hydroxyproline until the methionine, we have 13 amino acid for bovine as only. So we can carry out uh, multivariate data analysis to get more meaningful information. Okay, so from this multivariate data analysis, we can identify the sample grouping. If you want to compare between different source of animal, for example, or different source of plants, for example, or if you carry out different treatment in your extraction, for example, and then you can carry out this multivariate data analysis, MDA, to find the relationship among the compounds. Okay. What else that we can get? We can identify significant variable contributing to the sample. Okay. For example, in this bovine, we have 13 variable that being analyzed in our laboratories. But that doesn't mean these 13 variable are meaningful variables for this bovine. So this multivariate data analysis, for example, we have PCA later and even the discriminant analysis, they can suggest us among the 13 variables, perhaps 10 only, perhaps 5 only amino acid here are meaningful for this bovine or that characterize the bovine sample. Okay, so that will become what are the consequence after that. If out of 13, only 5 the meaningful one, we can save a lots of chemicals. Yeah, we can save the environment so that we don't have to analyze 13 variables if we already stated that only 5 are the meaningful one. This is really practical, especially for environmental samples. Again, I just want to bring back what we did in the MOSTI previously. So, for example, we have lots of rivers in Malaysia, and usually in the monitoring location in rivers, there are up to 70 parameters that need to be analyzed in one river water analysis, but actually only 25 variables are the meaningful one to indicate any pollution in our environment. So in this case, we can propose what we did previously. We proposed to Department of Environment. So can we just proceed with 25 variables so we can cut costs, lots of chemicals and money for the government spending, because we can, out of 70, we only need 25 variables. Okay, so this is similar what we can do for our study, eh, even though in food. Okay, what else? Yeah. Mm, mm-mm, mm-mm. Ah, B B25. Mm-mm. Oh, yang ni we carry out replication. Kita run banyak kali. Ah, tak ada. Yang ni kita decide dulu. We decide on our own lah. Okay? Yes. Mm-mm. Okay. Okay, we will look later. Sometimes replication, it's not sometimes, replication even treatment, you can improve the numbers of treatment as well to get more data. Okay, because when you have in the preliminary part, the part A later, afterward, it will we will try to check whether your replication, your treatment are enough or not enough. So if it is not enough, you need to increase the numbers of replication or even adding more variables in your study. But there is an indicator. Okay. So what else that we can get from this multivariate data analysis to predict sample grouping? For example, uh, we can get this bovine. We can also analyze amino acid in fish and in porcine, and from there we can make them as our database. Then, when another client or your client sending a sample to you, you can analyze the same thing, the amino acid, and we can use the multiple varied data analysis to predict the unknown sample coming from your client. Is it from the bovine source, porcine source, or fish sources? Okay, so this is the prediction of sample grouping. This one we can do using discriminant analysis. Okay, and then usually in food sample, data are becoming increasing multivariate in nature, and response measures comprise several univariate types, including sensory and instrumental determination. So, what previously I've been assisting, there are some lecturers from different universities. We assist them to find the chemicals data and try to link with the sensory evaluation by the panel of your sensory studies lah. Okay, for example, if they say that there are some particular smell that not being we call it one preferable by the panel, we can link back which possibility that this smell coming from which chemicals. So this is the assistance that we have been providing to the in-house clients lah. Okay, so the data becoming increasing multivariate, so that's why we are promoting multivariate data analysis. Some people they may say that the word of chemometrics, chemometrics, this is also a multivariate data analysis, but they are using chemical data. If you found some term of, for example, econometrics, it's still using multivariate data analysis, but the application is on economy. Okay, so actually it's similar, but that's why I promote to use the multivariate data analysis to say that this technique, these statistical analysis are not meant for food only, even though the title of our workshop is in food studies. But in this session, this one day session, the data that I'm going to share with all of you, that we are going to have the hands-on, are more related to food. Okay, so the application on food. Okay, so this is what we call it multivariate data analysis. Okay, so up to this level, before we start, I would like to have a 10-minute breaks, 10-minute break, and then we will continue. Okay, so because I also need to assist other participants, the face-to-face one, some installation cannot be done, so we need to install it first before we move to the uh, proceed to the session of the this workshop. Okay, so we will come back later at perhaps 9:55. Is it okay? So we will continue with our session at 9:55. All right. Okay. So let us proceed to the next slide. Oh, ni pergi buka yang awal balik eh. Okay. So we will proceed to this part A, prerequisite of multivariate data analysis. Okay, masuk dia dekat sini. Apakah keperluan-keperluan sebelum kita buat multivariate data analysis? What are the requirement that we need to fulfill before we conduct the multivariate data analysis? Okay, so this is the meaning of this topic. Okay, which is lacking in any food studies. If you read about environmental study or research, they have a quite proper flow, uh, so that everybody can adopt the similar approach. Okay, most of the time, especially in the field of my halal, related to halal, they just simply take the data from FTIR, so on and so forth. They just proceed, jump into PCA without confirming whether the data is enough or not before we carry out any multivariate data analysis. Okay, so in this case, uh, the problem is, if we don't try to comply with the requirement, so you may proceed with producing a results, but perhaps it's not meaningful, or it's not really representing the actual data. Okay, you kena ingat, tuan-tuan puan-puan kena ingat, everybody shall be bear in mind when we talk about statistical analysis, statistical tool like this XLSTAT, SPSS, so on and so forth. What you give, you will get the result. If you put the rubbish, you will get the rubbish result. So we would like to avoid that one. That's why I promote to have this prerequisite first before we proceed to any multivariate data analysis. Okay, right. So what are those? Yeah, so in this prerequisite multivariate data analysis, actually there's a lot of prerequisite of multivariate data analysis, but in this course, I just provide one of the main uh, requirement. Okay, the first one, you need to evaluate of your missing data. We will look later what is the missing data, and then we need to identify, or perhaps we need to remove the outliers. Okay, uh, we also need to collect, or confirm whether the data that we have collected are really adequate. Cukup atau tak? Alright, it is enough for multivariate data analysis. We have to confirm that one first. And then we need to perform assumption test of multivariate data analysis. There is some assumption, meaning that it should be normally distributed. Okay, so let's go first to evaluation of missing data. Okay, so missing data occurs due to undetected variable or detected variable that is below the limit of detection. Eh? This usually occurs in method validation and verification works. Some studies, they need to develop a new method. Dia buat satu method baru, lab testing for example. So, they need to carry out a method validation and verification. But in certain case, the compound that they want to detect are not appearing, or is not eluting, for example, in the GCMS. So in this case, you will get a result which is perhaps 0, or even you put ND. not detected. Okay, so you need to evaluate this missing data. Okay, so the common practice to address this missing data is you need to convert the value between LOD to zero point 0.5 LOD or 0.75 LOD. LOD means limit of detection. Yeah. But now the updated information, you need to convert the undetected value to 0.65 LOD. Okay, so, yeah. Okay. So it is recommended since only fewer distortion are reported when this step is tested on the MDA. MDA mean multivariate data analysis. So we have to bear in mind. Kadang-kadang tak tahu pula MDA ni apa. Perhaps saya tak letak in, I don't put it in the previous slide. So MDA mean multivariate data analysis. So you need to times 0.65 times the LOD, limit of detection. Okay, so where this LOD can be retrieved. Okay, you can see at the table 2, this is another example. For example, the test that I carry out is we need to identify amino acid. This is our parameters. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 17. So we have 17 amino acids that being detected in different sources of animal. And each of these amino acid has their own LOD, meaning that this is the lowest concentration that this hydroxyproline will be detected by the instrument. Meaning that if there is a peak of hydroxyproline still appear, but it below this 9.85, so you cannot report it as zero. It shall be reported as well, but you need to times this 0.65 with this LOD value. And then put this result 0.65 times to LOD into our data set. Okay, so this is the meaning of missing data. Perhaps it's not applied to everybody's research, but those research that involve developing new method or creating a detection analysis. For example, in my previous laboratories, we are offering court cases. So we need to develop method forensics, environmental, biotechnology. So and then we need to report to our for court, become the expert there. So we need to carry out this LOD test in the instrument lah. So in this case, the amino acid is analyzed by using HPLC or high performance liquid chromatography. So each of these compound having their own LOD. Okay. So in this case, if you, yeah, okay, yes. Okay. Are you developing a calibration curve or not? No. So you don't need to do LOD. So this data that we have is based on calibration curve. So if your study only to identify the profile, for example, I have an olive oil ataupun I ada palm oil. I just want to know what are the compounds in the palm oil. Just want to know. So we just run as it is, make it into a percentage, get the area, and then convert them into percentage concentration. But you don't need to do this LOD because we just want to have that profile. Qualitative, no need. Quantitative, you need to do this evaluation of LOD. This one saya memang buat calibration lah. Ya. So having this calibration, you akan dapat this LOD. Mm-mm. Tak perlulah. Direct saja. Direct take the value. Yeah. So if there is a peak, tapi tak ada area dalam you punya GC tu, you just report as zero lah. No, you takkan apply this missing data punya approach lah. Okay. So it's not meant for everybody's research lah. Different research, they have different approach. If you're having problem about this thing, after this workshop as well, we call it after sales. free, tak ada apa-apa masalah, you can just simply contact me. So I will assist you on choosing or advising you which approach is suitable for your research. Even if you want me to outline your PhD as well, it will be simple. Okay, so this is an LOD thing. Okay, and then, yep, yes, again, macam mana? Uh-uh. Mm-mm. 0.5. Okay. Okay. I just want to tell you, previously, people just simply use 0.5 sampai 0.75. But the recent research studies, 0.65 is the best. Okay. So previously, macam-macam approach people do to treat this missing data lah. So whether they just want to use 0.5 or 0.75 until 0.75. Ada yang pakai 0.6. There are some people using 0.55, for example. But from their comparison, 0.65 is the best lah. Okay. Uh, but if you asking me about which papers, I need to look back. I lupa nak cite lah which paper that state about that 0.65. Because those people that using this LOD for missing data treatment, you need to cite the paper, right? In this case, I am forgot to attach this one. I need to look back which paper. But the one that I read before when I prepare this PowerPoint slide is 0.65. Okay. So in this XLSTAT, where we can treat this data as well, we can having this missing data where the approach, other approach selain 0.65 ni, you can use do not accept missing data. You don't want to accept at all. You can remove the observation, meaning that the sample itself. You can pairwise the deletion. You delete the system will the SSL will delete your data itself, where it's having the missing data, or you can even estimate some of the missing data into mean or nearest neighbor. Okay, so this case yang dalam ni, this in the case of you get a result, a data from other parties, but you don't have full information, meaning that you get a report stating that the results having ND. Dia tak sebut pun zero. Kenapa dia just sebut dia ND. And they don't tell us about the LOD, so on and so forth. So we don't have any option even after we contact the third party. In this case, like for example, macam myself, I carry out some multivariate data analysis services to industries. Sometimes the data that they give to us is the one coming from another parties where we cannot get the access. So it's state ND. So in this XLSTAT, they also provide an option. Kita nak buat apa? What we can do for this data that we don't have any access. So you can choose do not accept missing data, remove, pairwise, or estimate missing data. In most of cases, I recommend don't remove the observation because you are losing your replication of your data. You choose to have an estimate missing data using mean or mode. Okay, but it's a case by case basis lah. Perhaps if you want to look into more on this one, we can have some discussion. Which one you want to choose? Okay. So it's not only one approach, not only 0.65 time LOD in this certain case, and then if in the case of certain occasion or event, you have to choose this option as well. But this is the option that available in the XLSTAT. Okay. Oh, ni tak perlu. Okay. Okay. So we move to the next step, which is another prerequisite, which is we call it identification and removal of outliers. Okay. So outlier ni apa? What is outlier? So outlier is defined as a variable value, satu nilai, that exhibit an extreme value from the majority's value. Okay. So what are some approach that we can to address this issue of outlier? Okay. If no sample grouping has been identified, you can perform box and whisker plot. Yang ni box and whisker plot ni contoh lah. This is the example. You also can carry out Grubbs or Dixon tests at alpha. This A here is alpha. Okay, I'm sorry about this one because I'm using the century Gothic font. So the alpha is written as A, of 0.05, 0.01. Okay, we will use this approach in this workshop. Okay, people will be asking again, so why 0.01? If we remember our statistical class, the most common people say 0.05, meaning that we allow to have 5% error in our statistical analysis, in our study, meaning that 95% are correct. This is 0.05. So if we have 0.01, that indicate we allow 1% error and we accept 99% correct. Meaning that correct classification, correct regression, correct prediction. Okay. Some statistical study, they choose to have 0.10, meaning that they allow 10% error with 90% correct classification, so on and so forth. Okay, so which one we need to do? So usually in food studies, we opt to use 0.05, environmental as well, 0.05. But in this note, I choose 0.01 because in my field, I am conducting halal authentication. In halal authentication, whether you have 100% pork or even you have 0.0001 pork is still haram. So that's why I choose the lowest allowance of error in my study. So in general, in food, people choose 5% or environmental as well, 5%, meaning that 0.01, 0.05 alpha. Okay, the lower the alpha that you choose, that indicate you allow lower error. But with this lower error, you will find your accuracy will be affected as well. Okay, so that's why people just don't want to have too low. They want to allow too high error to be accepted. So they choose 0.05. Okay, so this happened when I was called by the government to become an expert witness in court case. So one of the lawyer being asking, so how sure you are? Some of the ship spill, the ship A spill the oil to our Johor shoreline, Pengerang area, for example. So during my statistical analysis, I just tell them, oh, I'm 95% sure. And then after the court case, my colleague asking, where you get that 95% sure? Yeah, because P is 0.05. So this is what the implication of our statistical analysis in our actual life condition. We don't simply learn statistics for the sake of learning, getting A, memorize the formula. That is why we've been bombarded all this while, starting from primary sampailah you punya degree, and then you don't know what is the application. So I'm not telling you I'm the best, but this is what I realized, the reason when I work. Okay, before that I even don't realize that one until when I've been called for court cases and I provide the 95% confidence level. So when the lawyer asking how confident you are, 95%. Why? Because the p value is 0.05. So this is the application that we can carry out in our life. Okay, so in this approach, I perhaps using 0.01 in this workshop. I might use 0.01 or 0.05, but that depends on your study. Okay, so decision of outlier treatment, you can remove the outlier or you can accept the outlier itself. Okay, in this, it is case by case basis lah. So let's talk about this data, for example. I have three type of gelatin, fish, bovine, and porcine. In the case of halal and haram authentication technique. This is in my field. Okay. So I carry out the fish gelatin. I analyze amino acid 40 times. I try to make as much as possible, as many as possible. Bovine as well 40, porcine as well 40. Okay, why I choose 40? Because remember in our statistical study in our undergraduate, they say that the N shall be more than 30. So I just adopt this one first. So I analyze 40, I make it higher because definitely there will be outliers being detected afterward. That's why I choose 40. Kita ambil lebih sikit. Okay. Kita kan dah terbiasa zaman-zaman dulu kalau orang tu cakap banyak tu kita mesti buat lebih sikit. Nak pergi sekolah, mak cakap beli baju. Kita nak beli baju, mak kata beli 2 helai. Macam tu lah. Okay. So this is the reason I choose 40. I make it higher. Okay. So from this 40 analysis, I carry out this box and whisker plot. And then this box and whisker plot will identify the outlier for each individual amino acid or variable. So you nampak this one, the black thing, black dot, this one. These are the outlier from our fish gelatin. And then I carry out a box and whisker plot for bovine. They also identify the bovine. Okay, for porcine as well. So from here, since I know that the fish gelatin, the data should be very, we call it, kita panggil apa, precise, should be precise. So all of these outlier are removed afterward. In bovine as well, all of these outlier are removed because I want to make it as a database. So this is the first case. Yeah? We measure the compounds identification concentration to develop a database with high repetition, meaning this 40. And then in this case of this case basis, we need to recommend to remove outlier for each database. Okay, perhaps this one does not apply to your data. For example, you carry out a food studies, you hanya ada 3 replicates. You need to remove it. Some of the case, you don't have to do it. Okay, so let's go to the second case. This is the case of one of the sensory evaluation. They carry out the sensory evaluation and then some chemical compound analysis or chemical and some bacterial analysis or microbial study lah, okay, in food. Unfortunately, in this study, they able to do a repetition for each of the sample 3 only. Okay, so they will get lots of outliers. Okay, so in this case, I don't recommend you carry out the outlier. You still remove the outlier. You can still maintain it as it is. Okay, yang ni tak perlu pun buat sebenarnya. Unless you still want to remove this one, provided that you run again your sample, get more repetition, and then you can remove this outlier. Okay, in this case of studies, some of the study we have the limitation of money. We have limitation of instrumentation. Okay, kejap rosak, nak beli semua susah, nak repair pun 6 bulan, 1 semester habis. Okay, macam complain je kan. But never mind, that's the reality in Malaysia. So, this is the challenge for you, so you don't have to remove this one in this case. But if you still want to remove it, choose the one, the analysis that easily to be replicated. Paling mudah daripada awal lagi, in the first place, increase repetition. That's why usually when we start to carry out studies, master or PhD, it's good to learn the statistical analysis as well as so that you can get this advice. We don't limit the repetition up to 3, go to higher because we know there is a potential of the presence of outlier at the first place. So if you want to remove the outlier, it will not affect your replication. So that's why we recommend. In some cases, if you go to multivariate data analysis expert, they recommend up to 7 or 10 replication for each sample. Yeah. So this is my recommendation lah.
Banyak outlier because minimal.
Minimal replication lah. So sometimes it's not representing the whole data set lah. Okay. Sometimes there's an error during analysis. Sometimes chemicals do not suitable. Okay, environmental condition. eh, Even sometimes the equipment is not maintained, is not calibrated. That will become a source of outliers. Okay, then the third prerequisite in this multivariate data analysis, remember kita tak masuk lagi PCA ni, kita baru masuk the requirement for MDA. You need to confirm whether the data that you have collected enough for multivariate data analysis. So previously, this is the lacking that I found in food studies. They simply analyze the sample, go jump to PCA, discriminant, and then the report. But they don't confirm whether the data set is enough. Okay, so in this case, we promote to have this Kaiser-Mayer-Olkin test, or we call it adequacy test. So in this case, since in my field is halal, so I choose 0.01 lah. But in food, you can choose whether 0.05 or you want to choose higher. But I still recommend 0.05 is the optimum lah. Okay. So from this KMO test, we call it Kaiser-Mayer-Olkin, you can get this result. They will identify the KMO value for individual variable, and then they can average for the whole data set. So for example, here you will get 0.287. Okay. And then whether you want to know your data set is enough for your MDA or not, you go to check with this criteria. So if the KMO value rank is less than 0.5, we call it inadequate, memang tak cukup, meaning that you have to increase the replication, tambah adding more variables, okay? Or if it is between 0.5 until 0.7, we call it mediocre. Betul ya sebutannya mediocre? Mediocre, sorry. And then if it is between 0.7 until 0.8, it is considered as a good. If you have 0.8 until 0.9, it is very good. And then if this KMO more than 0.9 is considered excellent. Kalau you dapat 1 is the best lah. But that is so macam unrealistic lah kalau dapat 1. So kalau dapat 0.9 is the best. Okay. However, this is the one that I found in environmental study. As I said there, environmental study, they are 20 years ahead of food related to this KMO lah. I'm not so sure with other field. So they have decided in environmental study, the KMO more than 0.5 is deemed as adequate for MDA. Meaning that the data set having KMO lebih daripada 0.5, more than 0.5 indicate your data is enough for the MDA. Okay. Why I choose this KMO from environmental study? Because when I did my PhD, when I did my food studies, when I joined in HUD, I don't find any KMO result being published from food. Mungkin that is my limitation, I yang tak jumpa, or maybe in the field of food they say that it's not really important, or they want to hide something, the data is not enough, but they want to publish as well. So that's why I require or propose this KMO in food lah. Sekarang dah ada because I'm one of the one that able to include the KMO in my study. So if anybody would like to follow, you can follow my paper. Okay, but I'm not saying this is the best, but this is the one that I found to check whether the data set is enough. Perhaps all of you might find other tests as well. You can share. But in my case, since I start with environmental study, this KMO is already there. But when we did in food, nobody has been publishing about this KMO. Okay? Yeah. Yes, actually. You try to make it at least 0.5 and above lah. Kalau you dapat 0.499, I recommend to no. Because it's too narrow between enough or not enough. Okay. There is some potential in certain case when we conduct this KMO. At the next step, you need to remove some of your variable in other tests. So definitely, if you run again, it falls to not enough. That's why I recommend please make sure more than 0.5. I don't put more or equal. I recommend 0.5 and above lah. Try cuba dapatkan Okay, but there is some cases allowed where in one particular study nobody has been publishing in their field the KMO value. There is one study dia buat they collected the result is 0.4 something, but still accepted for publication by the reviewer because in that particular field nobody has been reporting about the KMO. Meaning that if there is another study, the next subsequent study carry out the KMO as well, they need to get the KMO higher than the one that been published previously. Meaning that the first publication stated about KMO is the trendsetter. We need to mention lah. But if nobody has been publishing about the KMO, you are the first one. Some reviewers still accept. In my case, usually, if I'm the reviewer, I will check, is there any KMO being published previously in that particular study? If there is no, so I just accept as it is. But I will recommend to improve lah, for if the same author want to continue the study using the similar data. Okay? Kejap ya. Yang kadang-kadang kena check dia punya recording. Okay, tak masuk recording dia cakap lah seorang-seorang. Okay, but the thing is I want everybody to watch again this video because I don't anticipate after you learn the one that I share, you simply can do it. I anticipate today you learn, tonight you try to redo, so you will not be, what you call that one? It's still fresh in your mind lah. Okay, so again, achieving a KMO more than 0.9 provide an adequate data set, especially when outliers are removed prior to the MDA. Okay, so you nampak tak sebelah kanan ni, at this side, the KMO stated here is 0.287. So, is it enough? Is it telling the data is enough? It's not enough, so in this case, if we are the one who study using this parameter, we need to adding more parameter to our data or adding more replication. Okay. Kejap. Sorry, kejap. Yes. Uh-uh. Uh-uh. Betul. Luckily dalam PCA dia akan calculate your KMO first. That one that is why and second reason why I choose XLSTAT. Mm-mm. Yes. Hmm. Okay. Nak tanya apa dah? Yes. Hmm. Mm-mm. 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 Yes. Meaning that if you have more repetition, your data will be more representative, the variable tu. So that's why dia akan assist you on getting high KMO lah. Lagi banyak data you collect, that's why it will be easier for you to do the MDA. That's why MDA, most of the cases, they don't simply they go higher than repetition, up to too many repetition sampai macam tak payah nak buat KMO pun memang definitely dapat 0.5 and above. Macam mana? You analyze dulu your data and then you carry out the KMO first. If the KMO below than 0.5, you have to adding more repetition and then go back to KMO to check. Sebelum buat PCA so on and so forth. Tu another thing lah. Tapi KMO tu kalau tak cukup, I tak recommend we go for MDA. You boleh je buat, provided macam I cakap tadi, you are the first one who in your field yang report the KMO lah. Okey, okey. Ada ni Encik Fizal. Ya, doktor, silakan. Silakan doktor. Mm-mm. Mm-mm. Mm-mm, betul. Bukannya treatment. Macam mana doktor maksud tu? Kita fokus macam mana? Ah, ah. Mm-mm. Mm-mm. Betul. Mm. Betul, betul. Mm-mm. Mm-mm. Dua-dua boleh. Kita boleh compare ikut different approach. Contoh, ah, ah. Mm-mm. Oh, okey. 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 Mm-mm. 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 Okey. Okey, faham. Mm-mm. Ya, betul. Betul. Mm-mm. Betul. Betul. Mm-mm. Okey. Kita akan jawab kejap lagi untuk next punya session. Ada normal Okey. 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 Mm-mm. Okey. Boleh? Boleh, boleh. Memang boleh guna. Multivariate. Boleh. Cuma itulah saya tak cerita pasal two factor ANOVA tapi memang boleh pakai untuk multivariate. Okey. Cuma before we move to the next session about this kita panggil apa normality tu. Okey. Requirement for multivariate data analysis is compulsory to normalize your data. Ingat dengan ayat dia. Kita kena normalizekan data kita. But if the data after normalization still stay the same, just proceed. Kenapa? Okay. Dalam dunia ni, especially environmental, saya cerita pasal environmental data, walaupun data dia sampai berjuta yang saya handle di Jabatan Kimia tu, tak pernah achieve normal pun. Walaupun selepas normalizekan. So, what we did, perform the normalization test first, normalize your data first, and then just proceed with the analysis. Sebab memang takkan achieve normal data you. Tapi jangan tak normalizekan and then you proceed. Whatever it is, normalize your data first. Whether afterward is still not normal or not. Kalau dia normal, baguslah. If it is still not normal, just proceed. Because usually after we make a normalization, it will not reach normalize. Dia akan near to normalize. Dia takkan cecah ideal. Ah, Data saya untuk environmental tu sampai berjuta tapi susah dan even tak ada langsung yang normal setiap variable. So my recommendation still carry out normalization tapi kalau dia still tak normal just proceed. Usually dia takkan achieve normalize. Dia takkan betul-betul normal. Dia akan menghampiri. It go near to normalize data lah. Okay? Boleh doktor? Okay? Hmm. Mm-mm. 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 Okey. Cukup sebenarnya kalau kita nak buat 3 replicate, no problem. Tapi macam saya kata tadi lah, jangan remove outlier lah. Just normalize, lepas tu proceed je. Tapi kalau kita ada treatment yang kita buat, kita nak remove outlier, you improve number of replication. Sebenarnya cukup saja dengan 3 tu. Ya? Tak ada masalah. Okay? Okay? Tapi please take note, saya pernah jumpa reviewer yang request very high replication lah. Tapi as far as I know, sebenarnya cukup sahaja kalau you nak buat 3 replication. No problem. Okay? Cuma yang normality tadi, that is the principle. Yang betul-betul punya sebab saya dah deal dengan higher number of data, memang takkan achieve normal. Kalau achieve tu, that will become bonus lah. Tapi requirement multivariate memang kena normalize data. Okay, so now we move to that normalized data. But the one that we are talking is not only normality, kita panggil dia performing assumption testing. Kenapa disebut performing assumption testing? Why we call it performing assumption testing? That indicate kita assume the data shall be assumed, bukan kita assume, the data shall be assumed to be normal. Okay, so itu first requirement dia lah. Another data assumption for our multivariate data, it shall be homoscedasticity. Meaning that, skedasticity apa? You boleh tengok contoh yang ni, the right side ni. Sepatutnya the distribution, variance of the data, dia akan distribute evenly. Daripada yang rendah until to high. Dia berterabur dekat-dekat je. It's not macam not even lah, should be even lah. But if you go to this next data, we call it heteroscedasticity. You tengok dekat tengah-tengah ni, at the middle side, too many data distributed there or located there or positioned there. So this one we call it heteroscedasticity. So another assumption that our data shall be homoscedasticity. Dia mesti distribute evenly. That is the requirement lah. So beside of shall be normal, it shall be homoscedasticity. Okay. Another requirement, sekejap saya pusing sini. Jadi kita pergi balik to this slide. The data as well shall show a linearity data distribution. Okay, yang macam ni lah. Yang macam yang cakap ni. However, this is case by case basis. Kalau if we don't really want to find any correlation, kita tak perlu pun nak find nak fulfill requirement of linearity ni. But it's the assumption that being given to data lah. Okay. So if our data is not normal, they are not homoscedasticity, meaning that they are heteroscedasticity, or the data is not linear, we only need one treatment, which is we call it data transformation, where this data transformation ada macam-macam cara. There are so many data transformation. We will show you later in the XLSTAT lah. Ada macam-macam cara. We have scaling, we have normal standardization. Yang atas ni. We can use standardized n-1, standardized n, center, standardized n-1, and then rescaling, Pareto, even log transformation. For microbial study, log transformation is proven the best data transformation. That's indicate along all these transformation that provided by the statistical analysis, certain study may have a specific the best data transformation. So in the case of microbial study, selalunya log transformation is definitely the best lah. So you have to test, kena try lah. Okay. So hanya cukup dengan data transformation. But again, baca bawah ni. However, transformation does not guarantee 100% normality, linearity or homoscedasticity. Yang ni yang saya bawa data 1 juta environmental case saya untuk sebancang di Jabatan Kimia tu, in the Department of Chemistry. It would not guarantee data kita akan normal. If it able to be normalized, that will become a bonus for us. So usually this transformation only need are telling us we need to bring the data set a normal or closer to the normality, closer to linearity, and closer to homoscedasticity. That's why after you carry out transformation, just proceed with your PCA. Mula-mula you buat KMO dululah. Make sure data cukup and then you transform and then you proceed lah. You nak buat PCA lah. You want to do the cluster analysis lah. You want to go for discriminant, so on so forth lah. Ada macam-macam lah. Kita ada k-mean clustering, so on so forth. Yang tu kita akan buat another workshop lah. Okay. So, this is my recommendation. So usually kalau I reviewer, if the author already carry out transformation, just proceed lah. Kalau tak buat transformation, I will recommend that to transform the data first. Okay, so jangan takut kalau after you make a transformation, data you tak normal. Definitely dalam dunia tak adanya yang betul-betul ideal. It will not become normality. Yang ni proven bukan saya saja, semua environmentalist researcher, environmental punya researchers, they achieve this one. Lagi-lagi kalau data you yang dalam lab saja, do you think you will get normal? Definitely not. Definitely not with 3 replicate. Lagilah. Okay? So, don't worry about this one. Make sure you transform data first and then proceed with your multivariate data analysis. Okay? Okay, sekarang dah 10.45. Saya cuba habiskan dulu hands-on on prerequisite ni. Yeah? So that lepas tu baru kita pergi ke PCA lah. Tapi kita akan rehat sekejap lepas tu. Okay? So now, we will go to hands-on on prerequisite of multivariate data analysis. Let's stop sekejap sharing this slide. Okay. Now, I want everybody to open a file. Okay. Nampak file, the one that those files that I want everybody to open, to download. Okay, so yang ni file. So sekarang ni apa yang I nak everybody to do. Okay, sekejap, I tukar balik. I share balik the slide. Okay, sorry this Google Meet ni kita pernah 4 kali buat session. Kalau I share dia punya screen, I akan dibuang daripada Google Meet. Kan trainer kena buang. So, kita kena share single file, barulah tak kena tolak. Okay? Ni hilang kat situ. Sekejap ya. Tak apa, ayah hilang. Sekejap. Kita masuk balik. Kenapa dia punya wifi dia hilang? Can share. Sekejap ya. Okay. Okay semua boleh balik? Masuk balik? Sorry Dia punya tu baru komplain pasal Google Meet terus dia bagi kan. Kejap. Alright. Saya kena tutup sekejap dia punya. Okay. So let me show the slide again. Sekejap. So before we move, okay, kita masuk ke this slide first. Okay, so the data we are going to do for hands-on of prerequisite is we call it large scale of multivariate data. And actually this data I extract from the open access file. Yeah. So we will carry out evaluation and treatment of missing data, and then we try to identify or identify the outliers using box and whiskers plot. And then I'm going to share about how to find the KMO. okay, from your data lah. And please take note on this explanation during the hands-on. Tapi jangan risau, this also a recorded version. So nanti boleh tengok lah. Okay. Some introduction about our data that we have. Okay. So the data that we have is about the information on packaging atmosphere, total mesophilic aerobic flora, lactic acid bacteria, unprocessed variable of 70 samples of poultry and beef sausages produced industrially in 2017. Okay, tapi this is not the original data lah. I obtained the original data but I amend some of it. Okay, amend tu mungkin the name of it is not similar, reflecting the one that I have downloaded lah. Okay, so this study monitored this variable to estimate the impact of packaging atmosphere in refrigerated storage period. They simpan this kind of sausages, poultry and beef, and then they have some treatment, and then they want to check whether the packaging atmosphere will impact the quality of the sausage. Okay, and then they aim also want to associate these process variable, all these variable, kita nak tengok the association. This variable include gas content in packaging, total mesophilic aerobic flora, total lactic acid bacteria, LAB, and then volatile organic compound, this one identified by GCMS, and some sensory evaluation lah. Okay, ni daripada study ni. Okay. So let me share again. Folder. Oh, sorry, this one. Okay. So, apa yang you all perlu buat, what everybody shall do now, please open the file number 1, 7 draft large scale dataset. Okay, dah buka. Sekejap ya. Okay, nampak yang ni? Saya buat full screen lah. Nampak? Okay, full screen. Okay, sekejap saya tak boleh full screen kot. Kalau full screen nanti dia jadi saya yang confused. Okay. Ini nampak So these are the variables. Kalau you tengok daripada sebelah kiri, on the left side, they have a meat type. We have poultry and beef. And then they put some treatment on the packaging. So they have packaging with nothing. They put air, some oxygen and carbon dioxide, some nitrogen and carbon dioxide, so on and so forth. Okay. So from here, they analyze these variables. Okay. Cuba you tengok So we have pH, packaging, aerobic flora, all those volatiles, and then sensory. Inilah sensory lah, dia buat sensory evaluation. Okay. Okay. So from everybody naked eye, saya bukan suruh buka cermin mata ya. Okay, you can see the red color ND located there. Okay, this is the case of yang I cakap, the one that I say missing data. For example, I from Kementerian Kesihatan, Ministry of Health, for lab punya testing, for example, I receive this data from Jabatan Kimia, for example. So Jabatan Kimia only state ND. And then when we try to contact them, we cannot, they say that they don't have any information. Perhaps the data is very old. Okay, so macam mana kita nak treat this data? Okay, so usually yang paling mudah kita akan remove ND ni, kita jadikan dia zero lah. Okay, that's the basic thing. But sometimes the XLSTAT also can assist us to find the ND. Tak payah nak tengok dengan naked eye, buka satu-satu. Yang ni nasib baik I dah merahkan. Itu belum kira lagi untuk orang yang tua macam I ni. Kalau the young ones, perhaps dia boleh tengok satu-satu lah. Yang ni baru hanya, this is the data that we have only perhaps hundreds. The one that we deal with, thousand, million, how do you want to find lah? Okay. So untuk this one, we need to identify the, we call it missing data first. Okay. How to do it? Go to XLSTAT. Kalau you open this XLSTAT and you see this one, there is an icon there, XLSTAT, you just click that one. Oh, sorry. Click XLSTAT. Sekejap ya, biasalah. Laptop dia sama dengan owner dia dari segi umur, so dia lambat sikit. Okay, so this is the XLSTAT feature that we have. Okay, unfortunately, yang I punya ni 2019 version. The one that you have perhaps the trial one is 2022, so dia lebih macam cantik lah. But those things that we need to click is similar. Okay, so the first thing is try to go for variable transformation first. Sebenarnya boleh je yang missing data tu, but I just want to go for variable transformation. Kita buat sekaligus Sekejap ya. Go to preparing data, click variable transformation. Okay, so it will be appearing this we call it window, small window. On the data itself, click there. Go to ph title, click ph title ni. Drag to the right to the last variable, old cheese, and then drag down sampai to the last value. Okay, and then on the observation label, click that one. Go to the left side, click the sample title, drag down to the last sample name. Boleh sampai situ? You want me to repeat? Okay, repeat So for again, saya tutup balik ni. Okay. Open your XLSTAT. This one okay Go to preparing data. And then click variables transformation. Okay, boleh? So it will appear one small window here. On the data part, click on the right side and then go to the title of ph reading, title of the variable ph reading. Drag to the right side, old cheese, and drag down to the last value. Okay. Then enter boleh. Okay. On the observation labels, okay, go to the right side of your Excel, click the sample title, and then drag down to the last sample name. Boleh? Okay. Dr. Tintan yang tadi dah boleh dah? Okay, okay. Sekejap lagi kita tolong Dr. Tintan. Okay. So, on this side, you nampak dia ada range, sheet, workbook. Okay, this one, if you choose range, you need to click which cell your result will be displayed. Kalau you click, if you choose sheet, the result will appear in the form of new sheet macam dekat bawah ni, yang variable transformation tu. Okay, and then if you click workbook, your result will be appearing as another Microsoft Excel. So this is how you want your result to appear. Okay, and then for display of the report header, you just click that. Okay, and then for transformation, kita choose standardized n-1. Okay, standardized n-1 is the most common transformation method. Kita ada banyak lagi, kejap lagi kita tengok. Okay, and then you can click OK. Okay, click OK, so it will appearing a new window, and then you can click continue. Okay, do you see this window? It will appear to say that the selection contains non-numerical data while it is expected to contain only numerical data. So dia dah bagi tahu in our data there is some we call it missing data lah. Okay, And then in this case, you have to look back at your data set. Okay. And then just in this case, you have to click cancel. Okay. So in the case of this, we know that this ND is the missing data. Try to replace with 0. Okay. What if you already found this one lah? Okay. And then carry out the similar variable transformation. Okay. Before that, if you look at this Excel sheet, the one that appeared as the Excel sheet and variable transformation, sample data, remove ND, these are the one that I have already prepared for you. So if you do it on your own afterward, for example, you want to recall back what you have learned this today, in this evening or tonight, you want to do it on your own, this is your reference lah. We already prepared for you. Senang masuk course dengan saya, semua dah siap. Okay, but uh, the most important thing you have to focus on mana nak klik. Most of the cases when we propose to have one particular software, people lacking of they don't know which button to click lah. Okay, so again, what if I have removed this ND, I change into 0. Okay, okay, you go to click this one, sample data dash remove ND. This one that the ND has been replaced with 0. Okay, we want to do a variable transformation with the correct data lah. Okay, so go back to preparing data, click variable transformation. Okay, kali ni just this time choose the sample data with choose the sheet which name as sample data dot remove ND. As if we already removed the ND lah. Okay, so this one carry out the similar work. Page reading, click page reading until to the old cheese, and then drag down to the bottom. Okay, and then on the observation label, you can click on this side and then go to the left side, click the sample name, drag down to the bottom sample name, to the last sample name. Okay, and then you have to make sure this transformation standardized and -1. Okay, and then you need to click OK, and then click, and when it is appearing another window, okay, so that's indicate you have 70 rows, meaning that 17 data. You have 17 column, meaning that you have you have 18 column, meaning that you have 18 variables. For observation label, you only have one column here. That's why they letak sini one column, because one sample name column. But you have 70 rows because you have 70 samples lah, 70 sausage in this case. And then you click continue. Okay, and then you can see there is another sheet appear as variable transformation 1. Why it's named as 1? Because there is already a variable transformation sheet. So when we carry out another transformation, so it will name as variable transformation 1 lah. So this is the similar result as it is macam ni, sama. Okay, so this one after you remove the ND. Okay, up to this level, sometimes participant will be asking, okay, what if I want to do other transformation? Kat mana lagi nak tengok? Okay, in this case, you can go back to the similar data, the variable transformation sheet, this one. Do you see this icon of play? Ada yang play ni kan? Okay, you click again the play button. You click the play button, and then it will bring you back to this, we call it Windows. You tak perlu go back to the preparing data, so on and so forth. Dia akan bring back to this window. Okay, now you click transformation other. If you click this other, this tab transformation will be activated. Kalau you click standardize, it will not activated because standardize and -1 is the most common transformation. But kalau kita nak cari scaling, we want to go standardize for population, log lain. Dalam tak ada log, I think. Okay. Other transformation, you go to other. So you can see this transformation tab will appear or will be activated. So when you click transformation, you can see a lot of other transformation methods available in this XLSTAT. So you can choose standardized, center, so on and so forth, and follow the similar approach. Okay. For food, uh, except microbial study or microbials data, most common food study that I found, they use Pareto scaling as the transformation. This is also the most common in food studies. Yeah? But the transformation N-1 ni, dia are more universal. Dalam food pun pakai, dalam environmental pun pakai. But as far as I know, from the papers in food, they use Pareto scaling. Okay. So this is how we carry out the data normality. Okay. So again, data transformation. So data transformation will treat the data which is not normal. They also will treat data which is heteroscedasticity. They also will treat the data which is not linear. Okay, so that is the assumption that already being imposed to the MDA lah. Okay, so this is how we carry out the data transformation. So lepas ni, after this apa yang kita akan buat? We will use this transform data untuk our PCA. Kalau you want to do cluster analysis, we want to do the discriminant, so on and so forth. So only the transform data will be used. Okay, again, if you carry out data and then it's still not normal, just proceed. As long as you carry out data transformation, it's already one step closer to normalization. Okay, so up to that session, we actually completed the prerequisite of MDA. But I have to remind everyone, this prerequisite, we treat the missing data, we treat the outlier, and then we carry out the KMO afterward, and then we will carry out the normalization. This doesn't mean that this treatment is the only treatment for that MDA, for prerequisite. Ada banyak lagi, perhaps I didn't find it, the latest one. Okay, but for now, this is the most common that I found. Okay. Okay, for the KMO, jangan risau, don't worry about that one. The KMO will come together in the PCA. Luckily, in the XLSTAT, KMO will be carried out in the PCA. In your PCA result, the KMO will be calculated simultaneously. So kita akan cover the KMO afterward lah. It's not much of cover. I just want to see the results. Okay, so sampai sini, we will continue afterward with PCA. But I think I recommend that we have a short break. Mungkin 10 bila? Pukul berapa? Nak berapa minit rehat? 11 berapa? Sekejap ya. Kalau, okay, 11.10, 11.20. 11.10 boleh? 11.10, 3 minit je. 11.20 boleh? 11.20 saya nak tolong Dr. Intan install kejap dia punya Excel. Okay, so we will continue later at 11.20. Okay, boleh sambung? Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, kita kembali. We will continue with the part B, which is principal component analysis. I think this part, lots of people are looking forward to know about this PCA, principal component analysis, or we call it PCA. So this PCA is the basic multivariate data analysis that people will look into. Tapi this one, I'm talking about my field lah. Okay, so we have this so far environmental and food. Untuk halal, for halal authentication, they will go for PCA. For this PCA, we can identify the significant variables in our study. But as well, in PCA of using this XLSTAT, it will assist us on calculating the KMO for us. So when we look at the KMO value, if it is lower than 0.5, we know that we need to add more repetition. Okay, so kita akan pergi kejap lagi. Okay, so some simple introduction of multivariate data analysis, especially on the PCA. So actually, there is a lot of MDA approaches or technique or method we call it. Okay, so we have here dependence method yang ni, or we can have an interdependence method. Sometimes people call dependence method as supervised method, or in this case of interdependence method, sometimes people will call it unsupervised method. Okay, so in this unsupervised method, PCA is one of it. Kenapa kita panggil dia supervised? Because we just take the data, let the system try to make the grouping, try to find the significant variable. We don't tell the system which are the significant variable, which are clusters, which are the clusters in this sample itself. So that's why we call it unsupervised. We don't push the system, we don't tell the system what this sample is about. It's like macam some unknown sample, let the system to analyze it. So we call it unsupervised. If we call them supervised or dependence method, especially in discriminant analysis, we will tell the system, this is bovine sample, this is porcine sample, this is a fish sample. Now, are they in the same group, for example? So we already tell the system what our sample means. So that's why we call it supervised. Supervised means we tell them, the system, about our samples information. Okay. So for PCA, or principal component analysis, is the most prevalent method in the literature. Yeah, this is proven. It provides an ideal route for introduction to multivariate data analysis, or MDA. Previously, PCA is different from factor analysis. But if you see here, factor analysis and PCA are grouped together. Because now the mathematical algorithm for PCA and FA can give the similar results lah. Okay, but I have some confession, which is I don't have a proper information why social sciences they prefer to use FA instead of PCA. So yang tu I punya, I think I need to dig further lah. But in science, we don't go for FA, but we go to PCA. But I think this is my task lah. I akan cari details. Okay. However, if we are dealing with the social sciences study, please approach the FA first and try to find the latent variables. As far as I know, when I previously I did some studies about the FA and PCA result, is still given a similar we call it results lah. Yang I bagi contoh sikit. Sekejap Oh, yang ni tak ada lah. Sorry. There is a slide in the previous session. We able to show the result of PCA and FA, and the result is still the same. Okay. But as far as I know, the algorithm are now similar. That's why if we cannot get the results of KMO in the PCA, factor analysis can provide the KMO. I will show you later macam mana nak keluarkan the XLSTAT as well as have their PCA factor analysis. Okay. So what does this PCA assist us in the multivariate data? Okay. So this is your original data. For example, we have this bovine data. We have 13 variables, 13 amino acids. Okay. So when we carry out the PCA, this PCA will create an uncorrelated data. We call it data loading, with the aim of to reduce dimension and to reduce the minimal loss of information loss. Okay. So usually when we have 13 amino acid, 13 variables, the PCA will create 13 principal component result. Yeah, this principal component numbers is correlated to numbers of your uh, variable. So kalau kita ada 13 amino acid, dia akan keluarkan 13 factor. We call it factor or principal component lah. Okay, so this reflect the numbers of your variables. Okay, okay. But if you see here, why we call it factor and principal component? Okay, in PCA result, usually we'll plot them F1 versus F2. Kenapa? Why? Because we have two dimension, part CX and part CY. If we want to plot F1, F2 and F3, it will become like this. F1 versus F2 versus F3. Baru dia buat plot. Okay. Okay. Is it clear? Okay. So in this case, if you have 13 variables, meaning that you have 13 dimension. But all of these 13 variables, we know we carry out PCA to find the significant variables. So in this case, PCA will assist us on choosing which variable are most significant. Usually, the first F1 and F2 result here will be plotted in the PCA result. That's why we call it, we can reduce the dimension. We don't have to plot F1 until F13. We just choose the most significant dimension, meaning that the most significant principal component or the most significant factor. Okay, so that's why we call it, we reduce the dimension. From 13 dimension, we can choose 2 dimension that covers all 13 amino acids. Okay, so this is what PCA will assist us. Okay, at the same time, even though we reduce the dimension, the information we will have some information loss, but at the minimum level. Okay. Then, apa lagi results that we can? What are the results that can be obtained from the PCA? Okay. So in PCA, someone want to join? Okay. In the PCA, you will get three plots. The first plot we call it variable plot, meaning that you take all the amino acid, you plot the amino acid. So that's why we call it variable plot. Because in this case, our amino acids is the variable. You also can get an observation plot, meaning that your sample plot. So that's why you can see here, this is the fish gelatin. The bottom one is bovine gelatin. The top one is porcine gelatin. Okay. Okay. The good thing from this PCA, you can see the distinct grouping. This one for fish only. This one for bovine only. This one for porcine only. Without telling the system, the PCA, what are the information that we have related to our sample. We don't tell the system, this is fish, this is bovine, this is porcine. The system create the grouping, provided that each of these group have their similar characteristic of amino acid. Okay, that's why we call it PCA is unsupervised, because the system do it for you. They try to find the significant variable, and from there, any sample that having similar characteristic will be located together in the same group. And that's why we call it PCA and unsupervised lah. Okay, the third plot we call it biplot. Biplot mean we take this variable plot, we put this variable plot onto an observation plot. Kita panggil superimpose, is it correct? We make an superimpose of variable plot onto the observation plot lah. So that's why you can see the red color here is your amino acid, and then it is put onto the the observation plot, your bovine, porcine, and fish. Okay, so from here, what you can see, any amino acid that falls onto the group indicate they characterize or they become dominant in that particular group. So you can see here histidine, serine, methionine are very dominant in fish gelatin. But you can see valine, uh, tak nampak apa lagi ni. Valine, thyrine, phenylene, they are dominant in porcine. So kalau nak cari sampel babi, tengok kalau banyak yang ni, kalau we analyze gelatin, if we have this dominant amino acid, so that indicate potential of porcine gelatin lah. Okay?
Plot bovine does not show banyak kali dia punya variable plot tu does not go to the
Okay. They have, but not dominant. Not dominant. Okay. Another explanation on this one. Okay. First, we go to this variable plot first. Okay. So from this variable plot, any amino acids that are located together, they are positively correlated. Okay, so in this study lah, in this gelatin study. So you can see here methionine, serine and histidine, they are high together. Okay, meaning that if there is high methionine, histidine also shall be high in this study. Okay, if it is located together. Okay, so any amino acid that located on the opposite direction, they are negatively correlated. So that indicate this methionine, thyrine, serine, and histidine are negatively correlated against hydroxyproline, HYP. That indicate as well if hydroxyproline is high in your sample, these 4 amino acid will be low. Okay, so this is the how we interpret the results. Okay, almost lah, almost 180 degree. Nanti kejap. Okay, okay. So another thing. Okay, can you see here alanine ALA here and lysine LYS tengah-tengah ni. Okay, they are located almost 90 degree against hydroxyproline. They also located almost 90 degree to these 4 amino acid. This indicate alanine and lysine doesn't have any correlation with this hydroxyproline and with the methionine, thyrine, serine, and histidine. So that is how we explain. Okay, apa lagi amino acid that are positively correlated? This one. Proline. Lagi satu apa? Tak nampak lah kat sini. Okay, proline. And then thyrine here. They are located and phenylene. Okay, they are located together. Okay. The nearer one here, glycine and arginine, they are also positively correlated among between them because they are located together. Okay, so this is how we read the PCA result. Okay, so if you make a superimpose or variable plot onto the observation plot, you will get a biplot here. So in this session, you can identify which variable, which amino acid are dominant in our samples lah. Okay, and then you bring this principle of variable plot to this biplot. Okay, let's see here, bovine. Bovine doesn't have dominant amino acid, but they have low glycine and arginine. Why? Because arginine are located at the opposite of bovine group. So kita boleh cakap if our gelatin containing low glycine and arginine, that indicate that gelatin may possibly from the origin of bovine. Okay, ada soalan ke tadi yang cakap? The length of the line. Okay, the length tu nanti kita akan tengok kejap, saya cerita balik. Okay. Ya, ya, silakan. Jap. Ah, yes, yes, betul. Hmm. Mm-mm. Top, bottom. Hmm. Ya, ya. Yes. Dia bukan tu sajalah, bukan tu saja. Okey, sekejap bagi saya jawab yang soalan yang tadi, kejap yang pasal length tu, saya delete ni kejap. Takut tak nampak banyak sangat dia punya merah-merah ni Sekejap ya. Saya tukar color. Saya ambil hitam lah. Sekejap. Okay. Okay, another thing you have to take note. Okay, this is our axis untuk F1. Decide until to decide. This one for F1. This one for F2 top to bottom. Okay, 2. So, any variables that located furthest away from the middle, this one lah, from the center, they have a strong factor loading. Maksud dia strong contribution. That is the length information lah. Okay. So in this case, methionine, serine, histidine ni, they are strong. At the same time, hydroxyproline as well strong because they are furthest away, regardless positive side or negative side. Same goes against F2. Alanine and lysine are also strongly contributed in this study because they are furthest away from the center. Bukan itu sahaja. This one, ni apa dah nama compound ni? Saya tak ingat. Okay. Even valine pun sama because they are furthest away. Okay. But you have to tengok dekat sini. Dia punya furthest away tu adalah dalam 0.6 something. They still strong. They still contributed, but they are moderately contributed because we are talking about furthest away from the center here at the axis lah. Sini sama ada ke sini or right to left side. Okay. So tadi yang soalan tadi cakap top opposite side kan. Okay. Contohlah valine kat sini. And then there is also one amino acid dekat sini. Since A and valine are on the opposite side, so that indicate they are negatively correlated. Okay. So to study the correlation, we investigate the direction between amino acid. But to know which are the significantly significant amino acid or variable in this study, go to the length. Okay. Another option to see on the length, we will see at the XLSTAT they have a factor loading table. That will be easier untuk tengok lah. But to study the correlation among the variable, we can refer to variable plot. Okay. So I hope you'll be answering, but it's okay. Kejap lagi kita akan buat, we will conduct the hands-on. The hands-on pun kita akan buat, but I choose another data set lah. Okay. Okay, so some application simple just nak share. So this is a few lecturers from INHAT, I think, Dr. Betania and Dr. Aizat. They talk about halal fish feed. So we know that in Islam, if we feed the animal with najis or even some haram material or haram feed, those animal we call it al-jalalah animal. Okay, so in this case, there are some cases in Perak, some ikan catfish, they were fed with the najis lah. So this catfish become al-jalalah. So we want to study what are the contaminant that can be found from this fish feed. So what we studied previously, we found some study from Lembaga Kemajuan Ikan Malaysia. They find out or they found no porcine DNA detected after 3 days. Okay, but there is a research from UPM. Halal Product Research Institute. Okay, in this study, I also being invited to join. So we don't go for DNA. We go for the we call it apa? Macam glycerol, fatty acid, triacylglycerol, so on and so forth. And then we try to study. Okay, so to know about which parameters, which variable are significant one, okay, we look at this table, we call it factor loading table. So from here, we can see any variable that having factor loading more than 0.75 is considered strong. If it is between 0.5 to 0.749 is considered weak and moderate. And if it is less than 0.499 is considered weak. So you can see here those bold factor loading indicate those triacylglycerol that is significant, that is a strong in this study lah. Okay, both in PC1 and PC2. Okay, so this also reflect the length, kedudukan of the direction lah. Okay, the furthest away from the center along the axis indicate they are strong. So you can see at this table directly. Lagi mudah lah. But if you want to study the correlation between these triacylglycerol, you go to the biplot. Dekat situ, from there you can find whether they are positively correlated, negatively correlated, or no correlation at all. Okay. Beside of that, there is also information if the factor loading having positive sign among them, that indicate they have positive correlation lah. Boleh tengok dekat sini juga. To find the correlation. But I recommend to find correlation. This one you don't go to the table. You go to the variable plot. That will become easier for you to see. Okay. Okay. Beside of that, sekejap. Sebab tulisan ni dah warna hitam kan. I need to change to red. Okay. If you see on this diagram, okay, you can see the samples, the triacylglycerol that we extract from the fish that being fed with the fish feed. Okay, fish feed. We able to differentiate them into 5 group. So the left side here is the fish feed containing 100% lard. The right side here, the fish feed containing 100% palm oil. 100% palm oil, you akan tengok dekat tengah-tengah, dekat right side lah. Okay. Those palm or fish feed containing mixture of blood and palm oil are located in the middle. So in this case, if afterward any people from, for example, client sending the fish feed to us, we can extract, find this triacylglycerol, use this database as reference. We rerun again the sample from client together with the database. We can see which sample, which grouping the sample will fall onto. So if it falls in the middle, that indicate the fish feed they received from the client having a mixture of palm oil and lard. If this is on the right side, really on the right side, it is 100% palm oil. If this on the left side is 100% on the lard lah. So you can see here, if it is not clear to you, you can see at the notes, L mean lard, PO mean palm oil. So this is the application that we found. This also added some value, indicate that even though the DNA, what we call it, of porcine, diminish within 3 days, but we can use this approach to identify, is there any lard being found in the fish feed after that 3 days. So from this study, we can bring forward to the Majlis Muzakarah, Majlis Fatwa Kebangsaan, so that they can issue a new fatwa. Even though previously in Islamic scholars say, so if fish is become ajalan, we need to quarantine them for 3 days. Some other animal 5 to even 7 days. But they are, in this case, they might be looking at the DNA. But how about the oil itself from that animal, the lard, for example. So this is another approach, scientific approach that we can assist in our Islamic background lah. Okay. But this is done by UPM. Yeah. I just assist them on the data analysis. They are good because they have apa equipment, quite apa enough equipment to do this study. Okay. So yang ni, this one just some PCA and factor analysis that I share to you. Remember in the previous slide, I told everyone that I don't find any differences between PCA and factor analysis. So this is the study that I did. I received similar or obtained a similar result, whether in PCA this side or whether in the factor analysis. Okay, this reflecting again about this slide slide yang sebelum ni. Kan kita sebut this one. This one. Yeah. Social science study, they use factor analysis, but sciences study, they use PCA. But the limitation of my study itself, I don't find the reason. So that's why I try to study on my own. I try to do this study. Having similar data, I try to conduct PC and FA, so the results are similar. So that's why I've been telling you, perhaps I need to try to looking forward. Mungkin ini tak ada dalam nota, tapi dalam my slide ni I ada lah. Okay, but it's still not proven yet. I don't find any citation that can support my finding, so that's why I don't share in the notes lah. But this is perhaps in the next session lah. Okay. Okay. Any question dulu? Tak ada? Kalau tak ada, before we have, yes, nak tanya? Yang mana? This one. Mm-mm. Sama. Mm-mm. Cuma I just want to, macam mana? Tak apa. Lepas ni kita buat hands on, kita akan tunjuk KMO value. Okay. Sekarang ni kita nak, yeah. Okay. So kita nak masuk KMO value KMO value tu kita perlu buat lagi awal lah. Tapi the good thing about XLSTAT, they will calculate in the PCA itself. Dia akan tunjukkan result tu. Okay. So before we have a short break, let's go to hands on first lah. Okay. Yeah. Macam mana? Total variance. Nanti dalam hands on Okay. Total variance also will be shared in the hands on lah. Okay. Okay, for hands on of PCA, kejap saya tutup dulu yang tadi. Banyak sangat file buka. Okay. Ada soalan ke? Okay. Nak tanya soalan pun you can put your question in the message box Sekejap. Alright. Oh, saya tak pergi dekat KMO tu kan? Tak apa, kejap Boleh tak kita pergi, can we open the number 4 first file, PCA? Dekat situ nanti dia akan share to you the KMO value as well. Okay? Number 4. Pergi dekat 4 dulu. Yang number 3 tu nanti kita boleh klik. Kejap lagi. Alright? Boleh? Sekejap saya tunjuk. Okay. Okay. If you see in the what we call it Excel. Okay. So this is data. We call it McDonald date sample menu. Okay. McDonald sample menu. Yang ni actually I took from some training, but I modified lah some of the data. Okay. So I choose this simpler data just to share with you on the application of the PCA. But for KMO, we will look at this data first. I also have provide one data in the KMO file number 3. We will look later. Okay, how to do this data analysis lah. So in this McDonald menu, okay, so we have 13 uh, McDonald menu. Kita ada 13 McDonald menu. So we have starting from this Big Mac sampai Sunday Caramel. Awal lagi ya, baru pukul 11.54. Not yet. Jangan lunch dulu. Okay. And then we have the variable is energy, protein, carbohydrate, fat, and saturated fat. Okay. Okay. So this 13 menu are being analyzed for energy content, protein content, carbohydrate. Ni kita panggil apa dalam food punya study tu? Proximate analysis. Yes, correct. Proximate analysis. So from this proximate analysis, we carry out this test lah. Okay. So from here, before we carry out PCA, you need to transform your data first. Okay. So how about we do the similar thing? Okay. If you click the variable transformation sheet here, your data has been transformed. Okay, kalau if you want to do on your own, you can use the similar approach, but I don't think so. I'm going to redo, but let's see how to do this one again, similar. Okay. Go to XLSTAT. Tu, baik dah. Tekan tadi. Ni yang ada angkat tangan ni. Okay. Alright. Okay. So to do this one, go to preparing data, click variable transformation. Again, and then click energy. Sekejap. Click energy title, click ada apa tu, and then drag to the saturated fat title, and then drag down to the last data result. And then on this observation label, okay, you have to click column labels. Column labels mean you want to tell the software the first row is the title. Okay, and then observation labels, click there, click the title of McDonald's sample column, and then drag down to the last Sunday Caramel name. Okay, and then click sheet so that our result will be appear in the sheet. And then click display the report header. For transformation, again, this one, just click standardize n-1, the most common transformation, and then click OK lah. So, and then you will get this window. Yeah, you have 13 rows of data, meaning that 13 menu. You have 5 column, meaning that you have 5 variables of proximate analysis. Observation labels, you have 13 rows because you have 13 menu and 1 column because you have 1 column of sample name, menu name. Okay, and then you click continue. So you will get a result as a variable transformation like this. Okay, so the one that I prepared is this one. I have arranged the column itself to make it a clear visibility. So this is the transform data. Okay. So from this transformation data, you will get a result of PCA like this. This one is already done for you. But to carry out on our own, you have to go to analyzing data. Okay. And then click principal component analysis, PCA. Okay, so you will get this window. This is for PCA. In this PCA, you will get claim O later. Okay, I redo again. I redo this one. So for PCA, sekejap ya. For PCA, click analyzing data, choose principal component analysis. Okay, and then at the part of observation slash variable table, what you need to do, click here. You have to click the whole. Sekejap tengok balik. Okay, you have to click starting from the energy, drag to the saturated fat, and then drag down to the last uh, value. Remember, you have to choose the transform variables, not the original data. Okay, and then data format, you have to choose or click observation slash variables table. Pilih yang ni. Okay, PCA type, click correlation Pearson. Okay, ada macam-macam jenis lain. We have covariance, correlation spearman. Kita pilih correlation Pearson because we want to find the correlation among this proximate variable. Okay, among this variable lah. Okay, why we use Pearson? Because this is a continuous data. Yeah, so that's why we use a Pearson. And then for sheet, sorry, for output of your result, click sheet. Please click as well the variable labels, and then for observation labels, you have to click there. Go to McDonald title, sample, and then drag down to Sunday caramel. Okay. So again, for observation labels, click here, go to the McDonald sample name, title, the column, and then drag down to the Sunday caramel. Okay. I will stop for a while. Ada apa-apa? Is it okay? Do you need me to repeat? Kalau perlu repeat, inform Okay. Kalau there is no repetition request, so I just proceed. So we go to options. Okay. This time for factor and filter factors and rotation, you just let it is, let it be like that. But for standardization, you have to click n-1. Okay, kenapa? We have to take note when we learn statistic, n-1 indicate we having a small sample. This is just a sample. It's not a population. So that's why we choose n-1. If you have biggest sample data, you can use n. But for myself, I still use n-1. Yeah? And then for supplementary data tab, just let it be as it is. Biarkan sahaja. Okay. For data options, you can see the missing data part there. Since this data already treating the missing data, there is no missing data found, so you just click do not accept missing data. Okay, and then for groups, just let it be. Okay, so for outputs, okay, for output here, click each box including the Kaiser Mayin Alkin, the KMO there. Nampak tak? Okay, okay, significant level ni is up to you. If you want to make it 5%, you just click 5. If you want to make it 1%, you have to click 1 lah. But that depend on our study. So in this case, I just want to let it be as 1. Okay, I think letak 5 lah. Sebab semua orang nak pakai 5 kan, food. Okay, kalau halal, I will go for 1 lah. Okay. And then for charts, okay, you have to click correlation charts and vectors, let it be. Sorry, for charts under variables tab, click correlation charts and vectors. For observation, you click observation charts, labels, and colored labels. Okay. For biplot, remember there is a plot we superimpose between variable plot and also sample plot or observation plot. Click all of it. But please make sure for type of biplot, you choose correlation biplot because we want to find the correlation in the study. There are also another options lah, distant biplot, symmetric biplot. But with the aim of our study, we want to find correlation between this variable. So that's why we click correlation biplot. Sometimes if you choose other type of biplot, you can still can get the similar result. But my recommendation, choose correlation biplot lah, because they have their particular algorithm behind it. And then for bootstrap charts, let it be. Okay. Do you need any repetition? Variable plot. Okay. For variable plot, correlation charts and vectors, you have to click that boxes. The rest let it be. Okay. Observations, click observation charts, labels and colored labels. Okay. For biplot, click each box, including the type of biplot. You have to choose correlation biplot.
The coefficient and automatic.
Coefficient ni pilih automatic Okay. For bootstrap charts, let it be. Mm-mm. Display chart photo tak perlu kot. Observation, yang ni observation charts, click labels and colored labels. Okay, boleh? Okay, and then click OK. So it will appearing okay. 13 rows, 5 column. Again, 13 menu with 5 variables. Yeah, and then you can click continue lah. So you will get a PCA result. Okay. Okay. Wait for this one. Okay, this is important part. Okay. Remember we talked about principal component. If we have 13 variables, you will get 13 variable principal component. Principal component as well can be named as factor, which is F. Okay, sampai situ faham So in this case, we have 5 variables. So you will see, you will get 5 factors here. Okay, same goes with this one, the ordinate 5 factors. So when you see abscissa and ordinate, that indicate the factor 1 and factor 1 and factor 2 axis lah. Part CX and part CY lah kiranya. Okay. So as I told you in PCA, since they want to reduce dimension, even though we have 5 variable, that indicate we will produce 5 dimension lah. That's why they produce 5 F1 until F5. But since PCA means to reduce dimension, they will choose the lowest, the first two axes or principle we call it, while collecting the most information. Okay? Sekejap Spider cuba tengok. You ada tutup tak? Sekejap. Tutupkan most information of our data. The whole data. Tutupkan volume Okay. So you can see here F1 versus F2, 75.99 of our data, yang data menu ni are meaningful. Okay. Yang ni based on what? Based on the factor loading nanti. Dia akan kirakan. Ya. No. Maksud dia F1 dengan F2 ni dia cover 75% of yang significant punya dalam F1 dengan F2. Maksud dia balance tu lebih kurang 24 something tu coming from F3 until F5. Okay. They will suggest the highest variability. Okay, kalau you tengok I buat dulu F1 versus F2, 75% of all of your data are significant, are meaningful in this study. Tapi kalau you choose F1 over F3, you tengok dia akan reduce 60%. So, do we need to why we shall choose lah the data that bring the most meaningful to our study lah. So that's why PCA they will choose for you the most meaningful F1 access. Okay, cuba you buat F1 over F4 47. Lagi rendah. So if you choose F1 versus F2, 75% of your 100% data are meaningful. So only 24% are big, not that significant lah. So that's why we call it the reduced dimension. Yeah, silakan. Okay. This one is a case by case basis, doktor. Okay. So macam I cakap tadi, sama juga macam yes, betul. That depend on your data. In my PCA data, in my amino acid data, we can go up to 90%, meaning that all the data that a variable that I collected in my study are really meaningful. So dalam this study, they can achieve up to 76% saja. So kalau you want more meaningful data, meaning that mungkin kena tambah variable lain selain of this proximate analysis lah. But again, that doesn't mean that it's not good because it's a case by case basis. Uh, Assess. Okay, macam I cakap tadi, this is case by case study according to field. Okay, according to field. The same like macam KMO. Okay, untuk yang halal on gelatin 80% 75% okay, boleh terima. Tapi kalau ada study saya pernah jumpa, yang ni kita buat untuk dia buat extraction treatment, they only manage to achieve 40%, still acceptable sebab tak ada orang yang buat lagi those kind of multivariate. Okay, so if you are the first one, you akan jadi trendsetter lah. So other people who cite your paper show having higher or similar. Dia tak ada cut off. Yes, silakan doktor. Kejap doktor, belum. Kita baru masuk lagi. Ada tanda? Belum. Kita baru awal-awal nak cerita the variability of data. Bawah lagi Okay. So, boleh? Boleh? Tak ada. Macam as I told you, it depends on your field. Dia tak ada cut off lagi. Tapi as we know, higher is better lah. Tapi macam case yang halal authentication tadi, less than 70 tu akan jadi query. Maksudnya that data is not enough. So dalam yang ni, I tak sure this data because this one I took from other people, but be able to achieve 76%. Kalau I want to publish the paper, I really need to check what other papers being publishing. Kalau dia punya tu 80%, that indicate my data is not really representative lah. Yeah. Yes. Kalau you are the first one, you are the trendsetter. You are the setter. You are the trendsetter. Yes. You yang mulakan dulu. Tak, yang tu based on principle masa kita belajar degree dululah. I letak N30. So that's why I increase for my study. I took up to 30. Dia depend. Macam mana? Tak banyak kan? 13 saja. So dia kena tambah variable lagi. Nanti you akan tengok this KMO pun sangat rendah untuk this data. So macam I cakap tadi, why I don't choose my previous data on amino acid sebab I rasa dia macam sangat besar. nanti laptop orang hang lah apa semua, so susah nak explain on the PCA. Now I want to explain on PCA, that's why I choose a very small data set and variable, as long as you can get the gist of the PCA lah. Yeah. Okay. Yes. Mm-mm. Mm- Mm-mm. Oh, tak. You jangan average kan. Ah, kalau individual analysis kalau you average kan, maksud dia you dah tak adalah replicate tu. Okay. Don't average. Yang ni pun kita ada dulu siapa yang contact saya, dia dah average dulu data dia lah. So I request to have the raw itself. Don't average. Kalau you just nak display in your paper or in your thesis in the form of ANOVA significant atau tak, you punya significant test, you boleh average kan. But in multivariate, you choose the single analysis, single replicate. Yes. Ah, rugilah kalau you dah average kan. What if orang tu ada 10 replicate, dia average kan? Rugilah dia. Okay. Okay, ada soalan sebelum saya move dulu? Yes. Mm-mm. Data ni tak replicate. Data ni tak replicate. Mm-mm. Yes. Burger 1, burger 2, burger 3 macam tu. Yes. Sebenarnya bukan lagi bagus, memang bagus. You kena ada banyak replicate untuk represent our data lah. Okay. Okey, sekejap yang offline kejap, saya nak tanya, ada yang offline ada tanya. Yang online kejap. Tanya apa tadi? Variability percentage. Cumulative variability kita panggil Okay, again yang this 75.99% ni, we call it cumulative variability. So, from the whole 100% data, variability that you able to achieve is 75%. Kenapa kita nak variability? Data you kena ada variable. Kalau dia sama saja, so no point lah buat PCA. That's why we did this multivariate lah. Nanti you akan jumpa tau kalau you buat banyak-banyak multivariate data analysis, if your sample punya result tu sama je, satu, 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 contoh result dia kan, atau 10, 10, 10, 10, 10, dia tak ada variability, so selalunya dia tak akan achieve KMO yang baik lah. Okay. Variability percentage ni pun takkan setinggi tu. So, that's why we need more replication. Dan selalunya takkan sama result tu lah. Okay. Boleh ada perbezaan tapi shouldn't be the same result dia. Okay. Okay. So, yes. Not yet. Not yet. Not yet. Not yet. It's just a factor. Variable will be look later ni soalan ni dah ke depan ni, saya tak masuk lagi. Okay, batch ni dia ke depan sikit. Okay, terima kasih. Okay, so for this one, we know that F1 versus F2 is the best. So we have to click select. After click select and then we click done. Okay. So you will get the PCA1 lah. So this PCA1 meaning that they produce a new PCA results lah. Okay. So for explanation, you click the PCA ni sheet ni, which is I have already make a description for each of this result for you, so you can refer to this one and then you can do the explanation lah. Okay tak? Sekejap Kalau trusted sources tu klik OK je lah. Jangan klik OK je. Okay. Okay, semua okay, semua boleh. Okay, sekejap
Actually, for manuscript or
F1, F2 in the best. Sekejap ya.
explanation
Ah,
you
tak.
can use
Tak,
the
tak.
thesis or the explanation.
Explanation ni you boleh pakai untuk you punya thesis. Okay. So, in this PCA, they will choose the two axes saja, F1 versus F2. Dia belum lagi dia tak akan plot, in this XLSTAT lah, they will not plotting for more than 2 dimension. Because they choose the most highest two dimension that having the highest variability. Okay. So kita tengok sikit-sikit dulu summary statistic. The first one is descriptive statistic. So from here you can see the result here. Dia akan cerita about sekejap ya. You nampak sini observation because we have 13 menu. Observation with missing data tak ada. Okay, observation without missing data definitely 13 lah. Okay. You will get the minimum value, maximum value. You have to take note kenapa dia dapat negative because this is a transform data. How do we know the data is transformed? When we find the mean is 0, standard deviation is 0. Kenapa? If we learn statistic previously, after you transform your data become normal. You can see the mean is 0. The -1 and -1 will become the first standard deviation. So that's why you get the standard deviation of 1 lah. So how do you know? So usually kalau you what we call that one, you request from your client or from your student, give me your raw data, the one that they have analyzed with PCA, you can identify whether they carry out the normalization or not using this indication lah. Okay. The second part is correlation matrix. Okay. Correlation matrix is just want to tell us whether among the 5 variables, are they having correlation? Correlation ni between 2 variables lah. Okay. Kalau you want to look more correlation, we will go to the PCA result, the variable plot. This one, we want to know the correlation between 2 variable, we will look at the correlation matrix. Okay. So macam mana nak explain? Okay. So you can see here, correlation matrix indicate that positive and negative correlation among the nutrients and has generic guideline. Betul nutrient. Okay, saya salah kot. Okay. So you can see here, okay, in this correlation matrix, they also provide a criteria. 0.7 until 1 is strong, 0.3 until 0.7 is moderate, 0 until 0.3 is also weak. So in this case, this guideline ni is a case by case basis according to your study field. Kalau you buat bidang-bidang halal, lainlah sikit. Mungkin dia lebih tinggi. Or if you are looking at other sensory evaluation, mungkin different. So please look properly at other publication as well. But if you are the one, this guideline, you are the first one who do it. This guideline is taking as a generic one. This one also from one paper of statistical analysis that I found lah. This in the case if you are the first one who carry out this correlation study lah. Okay, kalau orang lain tak pernah buat lagi, you can use this guideline. Kalau tak, if not, please refer to other publication. Make sure it's similar or higher. So on the correlation matrix, so we can see that based on this guideline yang ni, based on this guideline, so you can see yang pertama, one example, energy versus fat, we have 0.8686 correlation matrix. So that indicate it is strong. It's strong kat sini. And proportional. Proportional meaning because they are positive sign. So energy, so meaning that in our study, according to when we eat McDonald's menu, any McDonald's menu having high fat will bring more energy to those who consume it. Okay. Okay, kalau you pakai menu lain, mungkin lain lah. Other menu maybe produce a different output. So, we have to know the scope of our study lah. So, in this case, this is the McDonald's menu. Okay. Also similar, kalau we refer to fat versus energy dekat sini. Sama sahaja. Okay. Because it is still the same lah. Okay. Another example, How about we go to protein versus carbohydrate? So you can see protein and carbohydrate having a correlation metric negative 0.7245. So negative indicate they are inversely proportional. Tapi adakah whether they are strong, moderate or weak? So actually they are strong. Sebab because they are more than 0.7. Again, this is based on generic guideline. Yang in this case, I don't refer to food study sangat pun. But that depend on your field lah afterward. So in this case, apa we can conclude? If you eat the McDonald menu that contain protein, usually it's not your eat when you eat. Any McDonald menu that contain high protein, they also contain low carbohydrate. Okay. Same goes inversely lah. Kalau those menu having high carbohydrate, the protein also will be low. Because that's why we call it inversely proportional lah. Okay. Okay, another test. Yang ni boleh additional lah. Nak pakai atau tak is up to you. Okay, this one we call it Bartlett's parity test. These tests to identify the presence of correlation. We want to find, is there any evidence to say that, a generic evidence to say that there is a correlation among the variable. Definitely yes, it's already proven here actually in correlation matrix. But in generic term, is it present of correlation? So that's why we call it, we can carry out Bartlett's parity test lah. Sepatutnya, kalau I'm the developer of XLSTAT, dah lah record masuk YouTube. I will put Bartlett's parity test result at the top. And then support by the correlation matrix lah. Okay. So you can use the Bartlett's parity test at the top first, support by the correlation matrix. Okay. From here, okay, the good thing about XLSTAT, they provide you the hash null and hash alternative. Okay. So read the hash null and hash alternative carefully. So in our study containing 5 variables, hash null say that there is no correlation between all the 5. Dia kata no correlation significantly different from 0 between the variable. But alternative hypothesis say at least there is a correlation between the variable. So actually it's already proven because we have fat versus energy. Carbohydrate versus protein. But in the generic term, is it there? So you can see the calculated one here. The calculated one here state about p-value less than 0.0001. The one that you set in the study is 0.05, which is much smaller, very small. So you can see the declaration, it's not declaration, explanation by the XLSTAT as the computed p-value, which is here, is lower than the significant level 0.05, this one. So we should reject the null hypothesis and accept the alternative hypothesis. So alternative hypothesis says what? At least one correlation presence in this study. Actually, it's one, at least, dia kata at least one kan, but actually we have 2 correlations lah, strong correlation. Okay, so you can use this Bartlett's parity test as a supporting lah, but actually it's quite generic. Okay, then we come to the request by which doctor tadi? This is the KMO that you are looking for. Okay, so the KMO say about Kaiser-Meyer-Olkin test. You can see the word here, measure the sampling adequacy. So they want to see whether our sample is enough or not. Okay, so the rank is as I told you before, the range in the PowerPoint. Okay, this is the range, 0.5. More than 0.5 is considered acceptable for multivariate data analysis. This is generic, 0.5. In environmental study, 0.5 is enough. But in food, as I told you, I don't find any during my study, so I still follow 0.5 lah. But as I publish a few papers now, the one that I found in authentication halal using gelatin, the one that I able to achieve is 0.7. So anybody would like to publish afterward, if they want to, if they support they provide the KMO value, they have to make sure they have this 0.7 and above lah. Okay. So you can see here, since the KMO is 0.2087, do you think the data set enough for multivariate data analysis? Similar question? No. Why? If you go back to the single McDonald's data, the data is only analyzed, the menu is only analyzed in a single measurement. There is no replication at all. Okay? Tak boleh. Sebenarnya doktor boleh je publish. Cuma as I told you lah, kalau orang lain tak pernah report KMO, you the one, okay je. Tapi for multivariate data analyst, they will require this one lah. Okay. Some explanation when I did my PhD, I punya rezeki tu murah sebab examiner I tak ada seorang pun tahu multivariate. I dapat 0.1 ke, 0.2 ke, nobody. Even when we send to external examiner daripada France pun tak ada komen langsung. Padahal dia ada sedikit chapter lah dekat situ. Itu rezeki I lah. So, kalau ikutkan, in this case actually it cannot be published lah. If you want to still publish, I think can go to lower journal lah. Okay.
Like this, dapat tempo dah very weak. We cannot do MBA lah.
Should be we cannot do MVA. Should be. Sepatutnya lah ya. So in this study, if I'm the one who collect this data, I need to do more replicate. Even I need to add more. Mungkin tambah fiber ke, sugar ke, something like that lah. Specific sugar ke, to add more. Ya, doktor. Boleh, boleh. And then go back to KMO, check balik dengan KMO lah. Okay, so this is my recommendation lah. Boleh saya beritahu, boleh saja publish. You publish lah, tapi you try to find a lower journal. Tapi boleh je hantar ke high journal. Kalau rezeki you, there is, bukan I reviewer, mungkin tak ada tanya. Tapi I still accept kalau you are the first one. Usually kalau I review, I akan check. Paper ni pun tak ada orang publish talking about KMO. Bagi je, lepas. Tapi kita akan recommend lah. Please do it better lah. It's up to you, doktor. Selalunya kalau doktor reveal pun, orang tak tanya pun. Redo.
Kali energy yang ada, kita tambah 3 lagi dari.
Tambah 3 yang variable saja lah. Tapi tak boleh, tak boleh. To do all. If you tambah sample, you have to do all lah.
Redo lah.
Redo. Redo for new variable, tapi kalau new samples, semua variables kena buat. Okay. Kan? Mesti ramai bising. Kalau Syirwan ni macam-macam dia demand kan. Tapi tak apa. Again saya tetap bagi cara kalau nak publish juga. Okay. Okay. So, okay. Now we go to this section. Yang ni ada peminat dia. Kita ada Dr. Aimi. Dia punya ni, peminat dia yang ni. Okay. Dia nak tanya on variability ni. Okay. So, this one, this is a generic result of our PCA. Okay, we want to know about the PCA punya result. So we know that we have 5 variables. So it will produce 5 PC ataupun 5 factors. Ingat PC ataupun factor sama je. But the plotting that we are going to get is only F1 versus F2. Kerana apa? Why? Because 75% of our data set are meaningful. This is why we call it cumulative variability. Okay, kalau kita pecahkan, if we separate this variability, cumulative variability, we can read them from single variability for each factor. So 41%, 0.88, 42% of variability tambah 34% dapatlah 75. 41% add plus 34, you will get 75%. That's why they plot two axes only, F1 versus F2. Kalaulah you take this data, you plot in 3D, meaning 3 dimension. You plot F1 versus F2 versus F3, so it will cover majority of your data. Better actually, 94.27%. Okay? So this XLSTAT, however, they only plot 2. But if you want to get more data to be included, you can get this data and then try to plot at the using 3D. So 94.3% will be covered from your data lah. Okay. Yang ni penting kalau all of you learn in the next session you nak buat bukan session ni lah big data nanti Inhat pun akan buat halal data analytics for halal science for example. Kita akan dapat banyak sangat data. So having more data in to access dah cukup bagus lah sebenarnya. Tapi kalau you nak tambah 3D, it will be easier lah. Tapi 3D ni akan jadi challenges in term of nak lihat dia punya result. Because 3D Okay, okay. Eigenvalue. Okay, eigenvalue ni, this eigenvalue is a value that is apa tu? It characterize the metric we are studying. Okay, as you got higher number higher number factor, the eigenvalue will be reducing. Okay, so actually eigenvalue as well reflecting the cumulative variability. You boleh tengok as a lower eigenvalue having higher cumulative variability. So usually kalau in environmental study they will say they will stop at eigenvalue at factor which having eigenvalue more than one only. Yang belakang-belakang ni dah tak penting dah. Kita akan ambil F1 F2 F2 lah. So this F2 1.7 eigenvalue 1.7 reflecting 75% cumulative. Okay. But if people asking you, okay, F1 berapa variability, how many the variability? 41% lah. F2 only 34% variability, but if we plot F1 and F2, we accumulate them, it covers 75% with eigenvalue 1.7. But now, untuk paper environment, they don't report eigenvalue anymore. They go for variability. Because we want to know from 100% of our data, how much they are meaningful. Eigenvalue tu not really reflecting, but they just have a trend lah. As an increased number of your factor, F1 until F2, eigenvalue will become lower, but variability will become higher. Okay. There's and some cases people just say about eigenvalue just to add information. Sometimes it's not meaningful. Even I this is my confession as well. When I learn about this multivariate in environmental study and then join or jump into food, environmental paper they frequently use the eigenvalue and then support with cumulative. So when I jump into food, I also follow the similar way of explain. But as time goes by, we know now enough with cumulative percentage lah. Tak perlu put eigenvalue tu because it's reflecting similar information. Okay. Kalau you nak baca lebih, you boleh tengok dekat sini lah. Sebelah sini I have provide the explanation for all of you. This explanation actually coming from this XLSTAT punya kita panggil apa ya? Tab ni lah. So if you don't understand the definition of these eigenvalues so on and so forth, we can go to XLSTAT help and then try to get the information from there. But the explanation that I wrote here, I try to relate with this data set. If you read from the XLSTAT help, it will provide a generic information. Yeah. So for this workshop, I try to explain it to make it reliable dengan or relate to our data set itself. So you can read this one. Yep. Tak. Kita yang try to identify what is F1 and F2. They just provide an information for you. If you want to know F1 to belong to which factor, F2 to belong to which factor, you are the one need to identify. Okay, I bagi contoh ya. So when I did apa tu sampling analysis on kita panggil environmental air sungai, we have F1, F2 and F3 is the best lah. So F1 actually after we analyze, we get the biplot so on and so forth. The grouping that we have, we found the location. What we did, we go to the site, the actual site, rupanya this pollution coming to this kind of factories. Kilang-kilang buat bateri akan hasilkan this kind of pollution. So that is the factor. Battery factories. Ada tu from sewage production. So those F1 and F2 coming from this FPCA, they just assist you which variable is high and low. And then they say in your study, there are two factors contributing in this study. So we are the one need to find on our own. Okay. But usually tak ceri um, tak, selalunya tak. Selalunya tak. We have to find lah on our own lah. So in this case yang environmental, I pernah buat macam tu lah. Yeah. Sometimes we have to cite lah paper. Okay, contohnya macam mana, how do you want to propose which factor, kita akan tengok in F1, kejap lagi ada below table, which variable belong to F1 or strong in F1. So from this strong, you can find the factors lah. Tapi yang ni McDonald menu you nak find factor apa? Macam tu lah. So mungkin tak reliable lah. So dalam environmental study tu sangat reliable sebab we want to find the contributor of the pollution. Macam halal pun no. Because we already know we have bovine, porcine semua. You nak, what shall I find the factor from there? Kadang-kadang tak perlu pun. Even review pun takkan tanya. Sebab you already stated about this one. Okay. Okay, so from here, variability ada cerita. Okay, this plotting, eigenvalue and cumulative ni also can be plot in term of scree plot lah. So you can see this is eigenvalue, this side, this axis, yang ni. Yang ni cumulative variability lah. Okay, so sama saja. You want to refer to eigenvalue table or scree plot, it's up to you. But sometimes people will use this scree plot just to show lah berapa cumulative variability. F1 versus F2. Yeah. And then these eigenvectors, so eigenvectors are the direction along which the particular linear transformation acts by flipping, compressing or stretching. Okay. Tapi ini boleh baca nanti. In simpler word, eigenvector is the direction of eigenvalue. So this your eigenvalue, they transform into another algorithm using an algorithm to produce an eigenvectors for individual variable lah. But actually tak penting pun. But just go to show you the direction. The direction that is important is factor loading. Okay. So factor loading, this is the one. Okay. Kita ada this F1 and F2. Okay. F1 and F2. So which one is this wrong? So you can see here, energy, fat in F1 Okay. In F2, the strong one is carbohydrate. Tak ada the rest is moderate lah. So if you want to find a factor, okay, you can see lah. Okay, from this high fat and energy, what are the potential grouping of food kat situ. Okay, so you can see this factor perhaps and having high energy and high fat mungkin burger sahaja. Carbohydrate mungkin yang tinggi kat sini those yang involved with sundae caramel, those dessert ke. So that is the grouping of F2 lah yang contribute more in our study. Okay. Negatively correlated lah. Tak apa yang ni. Yang ni no. We just want to know the significant one. Kalau you want to go for correlation, kita akan tengok biplot yang ni. Ni, this one to negative positive tu. Yes, bukan tak boleh, boleh, tapi not lagi senang nak tengok. It's easier for you to see correlation. Tengok dekat sini, sorry correlation lah. Opposite correlation using this ni lah. Using this variable plot. If you want to see significant variable using the loading, you tengok dekat factor loading punya table. Significant variable in our study yang strong, moderate, low. But if you want to see Energy ni ada correlation dengan carbohydrate ke, dengan fat ke. It is better to use variable plot. Senang nak tengok. So you can see here carbohydrate versus protein, dia negatively correlated kan. So any menu having high protein, having a low carbohydrate. Ini pun supported by correlation test yang atas-atas ni tadi. Yang ni kan ada correlation test. Yes, yang ni. Dia support correlation matrix kat sini yes. But this time, kenapa kita pakai variable plot? Because this one, they analyze semua variable. Correlation plot, correlation table, matrix tadi, they only tell us about correlation between two variables. Ni untuk dua variable saja. But this one, kalau data you banyak, more variables, lagi senang tengok dekat sini lah. So you can see here, energy and fat, they are located together. Bukan together lah, nearer. So any menu having high fat will produce high energy. Any carbohydrate that menu having high carbohydrate, they have low protein and vice versa. At the same time, cuba you tengok saturated fat ni, dekat F1, dia punya factor loading je hanya 0.3 or 0.4. So they are actually almost weak contribution dalam kita punya study. So in this case, afterward we can propose anybody who would like to study about food, especially in proximate analysis, saturated fat can be removed in our study so that we can cut off cost of testing saturated fat, for example lah. Okay, so this is another example explanation. Tapi F2 dia dah tinggi, so dia dah strong lah. Boleh. Even though carbohydrate ni is quite low factor loading in F1, tapi very strong in F2 sebab dia dekat more than 0.75, so it's still significant in our study. Okay, contribution of variable, they just want to show to us how much these variables contribute in our study. Okay, so you ambil je dekat sini, you can see which one lah. Okay, same like here, squared cosine of variable indicate the significant contribution of the study. So sama je. Actually, what you can obtain from this factor loading already explained. This result yang they calculated ni just macam supporting if you want to support lah. Okay, factor loading is here. Square, cosine also support this result. Okay, boleh lah kalau nak pakai. And then we have factor score. Factor score is calculated for observation plot. Ni, plot yang ni, this one, coming from this table lah, factor score. They calculate the factor score first and then they plot F1 versus F2 to get this observation plot. Sekejap saya kena kecilkan sikit. Okay. Okay, so from this observation plot, what we can see, try to find the grouping of the similar menu. So you can see all burgers in the one group. Ni kita ada apa ni? Home fried. Kalau saya salah sebut cakap betul Dr. Intan? Apple pie in a group. But you can see all these dessert, ice cream, sundae caramel, sundae chocolate, sundae strawberry are located nearer to each other. So in PCASL as well, the result stated that if the sample is located nearer to each other, that indicate they have a similar characteristic lah. Not the same one, but similar trend lah. So you can see all burgers in a group. Tapi adalah fillet of fish punya burger lain sikit keluar sebab there is a chicken and beef burger dalam ni dominate. That's why fish fillet ni terkeluar sikit sebab dia ikan. Yeah. Positive related. Oh, untuk ni burger ni. Okay. For observation plot dia tak apply tau. Positive negative correlated among ni. Dia tak pakai jauh atau dekat ni. Yang those positive correlated furthest away from the center tu untuk variable plot. Variable plot. Ni plot yang atas ni. Kalau if you want to tell about the sample, the burger, the menu itself, kita tak pakai. From this observation plot, you can see the location. Are they grouped together? This one more on clusters. Yes, betul betul. Ah, ah, saya suka soalan doktor ni sebab itu ada dekat yang bawah. Yang ni. Soalan doktor dia terlebih sikit awal. Okay, inilah dia contribution lah. So kita plotkan variable plot yang atas ni. Kita copy ni, kita paste on the observation plot, so we'll get this plot. We call it by plot. Okay, so you can see all those burgers, they have high protein. Yeah. Yang pommes frites ni dengan sundae caramel ni, they are contributed more by high carbohydrate lah, walaupun dia jauh sikit. Okay. At the same time, these burgers having low carbohydrate sebab they are negatively correlated dengan carbohydrate, opposite direction. However, for sundae caramel, sundae chocolate and strawberry, this one group ni, saya kena lukis lah patutnya kan. They having low energy and fat sebab they are different opposite direction lah. Opposite direction. These burgers, they have low carbohydrate because they are in the opposite direction of carbohydrate. But they are high in protein. Okay sebab dia terlalu ni, saya delete balik. Kan orang tak nampak. Okay additional punya information tu you kena baca kat sini lah. Sebab rasa macam takut sikit, kita dah nak masuk pukul 1, PCA pun tak habis lagi. Kita ada cluster, kita ada discriminant, kita ada multiple linear regression. Okay? Okay. Okay, from here apa lagi yang boleh buat? What we can do afterward? Okay, you can try to find why pommes frites ni they having high carbohydrate or high energy, so on and so forth lah. So you can see. For me, I will dig down. Pommes frites is being cooked with what? Or what are the ingredients? So we can see potato oil, apple pie because it contain of deep fried. They are cooked in the deep fried. So that's a possibility why they have this energy high or low saturated fat lah. So again, PCA only assists you on the direction, location, grouping of your samples, but you are the one need to find this information. Sometimes dia guna nama Big Mac. Rupanya kenapa why they are located together with McFish, because they are actually beef. Okay. You can see Big Mac, McFish, cheeseburger, they are beef. Quarter pounder also beef. Hamburger also beef. Okay. So macam tu lah. So you can see why mac chicken and grilled chicken are together sebab they are chicken. Kenapa fish ni tercampak jauh? Why it's located further away? Because they are fish. Because the middle one, most of them are burgers from beef. Ada orang ketawa ke? Kelakar dia punya jawapan ni. Okay. So you have to kelaparan. Okay, kejap ya. So please again PCA, you punya statistical analysis, they only assist you. Nak buat apa, how are the location, how far they are, how significant the variable. But you are the one that need to investigate further. You are the detective lah. Kenapa dia macam tu? So kita takkan stop. We don't stop at this. Nak cerita dia positif, negatif je. No. We have to dig down. Kenapa dia macam tu lah. Tapi because this topic, this data is very simple. Menu McDonald. So I tak adalah dig nak detail lah. I dig up to this level saja. Why the possibility they are grouping together lah. Okay. In your data, you have to do it. But if you need some assistance, mungkin I boleh assist on propose lah why dia dekat ataupun jauh or different grouping or similar grouping. Okay. So the rest ni pun boleh baca, but this is square cosine, so on so forth lah. Okay. So kita dah habis dekat PCA. Okay. Before we stop sekejap. Stop sekejap ke nak proceed? Okay, tak apalah. Kita rehat dulu. Kan kita sambung cluster tapi kena laju sikit lah Is it okay? Faham tak yang PCA ni? Make sure you understand the PCA because this is the most sought MDA. Sebelum orang pergi ke cluster lah, orang pergi ke discriminant lah, multiple linear regression, PCA kena faham dulu. Okay? Tak ada eh? So I hope everybody is okay. Kalau ada masalah, if you have any problem, boleh kita panggil tadi apa? After sales boleh contact balik. Nanti insyaAllah saya cuba assist. Mungkin kita buat Google Meet lah kalau nak tahu lebih pasal ni. Okay? Ya. Mm-mm. Yes. Mm-mm. Oh, okay. Saya punya recommendation, you start dengan this KMO dulu, and then you start with this cumulative variability because we want to tell them we have F1, F2, how much the variability, and then you proceed with the ni. Alah, mana dia punya graph tu this variable plot. Sorry. You proceed with this factor loading dulu. This factor loading, you have to tell them the significant variable in your study in F1 and in F2. Even though we can tell them we can choose only significant, tapi since you are talking about the variable, you ceritalah sekali moderate, weak dengan moderate. So banyak explanation dekat situ lah. You can explain. Then you go to this variable plot to show about or to tell about correlation pula. Positif ke, negatif ke. Okay, sekejap. Ni pun tak habis. Carbohydrate and fat, the direction is almost 90 degree So in this study, you can see fat and carbohydrate almost having no correlation at all in this study. In McDonald menu. No correlation. Yes. Less tu adalah. Less tu maksudnya they are nearer lah dekat you kan. Nearer to each other. So yang ni kena cerita untuk correlation. Untuk nak cerita strong, weak, moderate, go for factor loading punya table. Okay. Tapi yeah. Tak ada apa. Doktor kena confirmkan ni je. Factor loading, sorry. Kita panggil apa? Axis ni je. Paksi ni. F1 and F2 ni. Okay. Okay, mula-mula kita, okay, saya repeat sekejap sebelum kita rehat. Start with the KMO because we want to tell them our data is enough. Jangan main-main cakap kat dia lah. Okay, for example and then you have this cumulative variability. You have to tell them F1 and F2 of our study covers 75 of all data. Okay. Then to show in our study the significant variables, go to factor loading table. Okay. And then to show the correlation among the variable, go to variable plot. Yang ni lah. Then to show about the grouping of the sample itself. Tadi before this is variable, this one is sample. Okay. So you have to go to observation plot lah. Okay. Then baru you explain on biplot. Boleh? So in biplot you will tell the reader which variable contribute or significantly contributed to our sample lah. And from there you have to dig why those sample having high protein, low carbohydrate. So sebenarnya itu sahaja tau dalam PCE. The significant one, the one that you need to tell. But if you, I think you can, I recommend you can read my paper. But it's not the best lah. But when I publish the paper using this PCE, so on and so forth, I pun baru nak merangkak waktu tu. I start to learn. So I just explain everything. Termasuklah cumulative variability, eigenvalue. Because I too used dengan environmental punya paper kelakar tau, I punya PhD, I publish 3 Q1 environmental paper, 2 saja Q4 study sendiri. Environmental paper tu yang Q1. Tu yang kelakar sikit lah. Tapi because to use with that, bidang sendiri dah ke laut. Okay, so You can refer to some of my papers. From there, you can tengok macam mana I explain lah. Okay. But it's not the best. Kita boleh cakap also learning lah. I have also taking the baby step for this PCA. Okay. So, kalau ada apa-apa, saya minta kita sambung nanti. Dalam cluster analysis boleh tanya juga walaupun pergi ke PCA. Tapi nanti kita try to laju sikit lah. Cluster, discriminant dengan multiple linear regression. Okay. So, jumpa lagi dalam pukul 2. Kita try to make it as soon as possible lah. Okay, thank you everyone. Okay, we will continue with the next topic. We call them as cluster analysis in food studies. So for this cluster analysis is quite simple. Okay. Okay. So this one, cluster analysis, most people are using it for clustering or grouping samples. So usually, since we receive a result from the PCA, we can get a grouping from the PCA. So people will usually adopt cluster analysis to support the grouping that being produced by the PCA results. Okay, so that's why this cluster analysis. That's why I'm just saying that just for grouping purposes, and at the same time, it's like validating the grouping that we obtain from the PCA results. Okay. So for cluster analysis, yeah, it is a classification method. So you can see here. Yeah. It will form subgroups of similar objects. Object means your samples based on assessment of the distance between measurement of similar characteristic of variables that indicate if you have samples that possess similar characteristics in terms of pattern or sometimes in terms of abundance of one particular or certain particulars variables, the sample will be grouped together in a one cluster lah, okay, or in different clusters according to their characteristic. Okay, so it also can become an exploration method that search within prior definition. So this is also, we call it unsupervised method. We don't tell the system, the XLSTAT, what are the meaning of our samples. These samples belong to which group, or so on and so forth. We just let the system to do it for us. So since we don't tell the system about the definition, so on and so forth about our samples, so that's why we call it then unsupervised. Okay. However it is, still again, we need to transform the data. Okay. And then this transform data will reduce some of the scaling or between samples so that it can be grouped together. Okay, so the result of cluster analysis, we call it a dendrogram. Kita panggil dia dendrogram. So from the dendrogram, we can draw a dotted horizontal line. Whether we usually we make it automatic, we let the system to draw the dotted horizontal line, horizontal yang kalau menegak vertical kan, so horizontal line. So any horizontal line yang across the vertical line of dendrogram will indicate the grouping. Beside of that, the cluster analysis also will produce a plot. We call it a profile plot. This profile plot will provide information on the distribution of variable in each cluster, meaning that if you have 3 clusters or 3 groups, each group in each group we can find or we can identify what are the dominant and least dominant variables. Okay, so how this dendrogram looks like this. Okay, so this is a dendrogram. This is an example of dendrogram where we combine fish, bovine, and porcine gelatin. Yeah. So this horizontal line that make an intercept with the vertical line indicate number of grouping that being generated automatically by the system. Okay, so in here we already know actually the sample contain fish, bovine, and porcine. So this, for the sake of just want to show the application of cluster analysis, so I just let the system do it. So definitely they produce three grouping lah, because we have three intercept there. Okay, it's just contoh. This is an example how the group looks like. And from each of this group, we have S2, S1, and S3. We can refer to profile plot. Okay, this is an example, but this one I don't use the gelatin. I just use the McDonald menu. So from McDonald menu, remember we have 5 variables. Okay, so now from this 5 variable, we call that one. This cluster analysis is able to group 3 grouping as well. Okay, remember we have the pommes frites in a group, those sundae caramel ice cream in the one group, and those burgers in one group. Remember, so we have 3 groups. So by looking at a one profile plot, this is a profile plot also produced by cluster analysis, we can know what are the dominant and least dominant variables lah. Okay, so for example, we have group 1 where this menu contain average energy, uh, protein, average protein. This one, oh, sorry. This one, oh, they call it average because they measure the high amount in average. Eh? Sorry, they contain high energy, bukan average, high energy, warna merah, the red color. They contain high protein, but they have a low fat. Okay, group 1 okay, if tengok balik sometimes they are a typo there. Okay, so and then high fat here and then high saturated fat. Oh, sorry, low carbohydrate. Sorry. So high energy, high protein, high fat, high saturated fat, but low carbohydrate. Group 2 are those McDonald's menu that having group 2 is the blue color. Average uh, energy, average protein, average carbohydrate, and then average fat, but low saturated fat, the lowest saturated fat lah. Okay, so the group 3, you have the lowest energy, lowest protein, the highest carbohydrate, the lowest fat, but average saturated fat. So these are the similar characteristic according to each group. So this is the grouping that we get lah. So since our PCA, we receive 3 group, we obtain 3 groups. So if you use the similar data, you conduct cluster analysis, you will also produce a similar 3 groups. So that's why we call it cluster analysis is one of supporting analysis to support the PCA. Just another option. So that's why not much can we get from there.
The cost analysis has two parts, your observation.
The dendrogram, your observation. Then profile plot is for variables. Okay, so it's just supporting documentation lah, supporting. No, macam audit lah. Supporting results lah. Okay, so from here, we can move to the hands-on. Okay. Unfortunately for XLSTAT in my laptop, I having problem. So I will use another laptop here. Okay, but I will open the microphone. So from here, I will stop sharing. I will go sharing from here. Okay. Could you go to cluster analysis file number 5? File number 5, cluster analysis. Boleh Try to open this one. Yeah.
HCA is cluster analysis. HCA.
HCA is cluster analysis. Yes. Okay. HCA means hierarchical agglomerative cluster analysis. This is akar. So it's part of cluster analysis. Yeah. Sama-sama. So that's why you can see the result below here, AFC lah. Okay. But this is part of cluster analysis. Okay. I hope everyone can hear because I'm using a different laptop to share and then different laptop to project my voice. Okay, so when you open this file named as cluster analysis number 5, So this is your McDonald menu. We use the similar data. And then the second sheet here, variable transformation, is the transform data also from the previous PCA that we did. So I just copy this one. So now we want to create a cluster analysis result, which is EHC. Yeah. So the result will be look like this. Okay, it's already done for you, but how to do it? Okay, you go to XLSTAT, yeah, and then go to analyzing data, and then you go to the bottom part, agglomerative hierarchical clustering, AHC. Okay, so this AHC is part of cluster analysis. There are different methods as well to do clustering. We can have k-means clustering. What else? We can also use fuzzy k-mean clustering. Yeah. But in this class or workshop, I just want to proceed with the hierarchical clustering, agglomerative hierarchical clustering, AHC. So again, analyzing data, go to AHC. Okay, go to AHC. So this window will appear. Make sure you choose the data from this sheet, variables transformation sheet, the transform data. Okay. So on this observation slash variable table, click here. Sekejap, click here, okay. And then click energy, drag to saturated fat, and then drag down to the bottom. Data, okay. Data format, maintain observation slash variable table. Proximity type, you can choose similarities of all these similarities, but usually people, if you use any, both of these will produce similar results actually. But for this class, I prefer to use the similarities, and then choose Euclidean distance. This is the algorithm that being used. Yeah. And then for agglomeration method, the algorithm that will be used is Watt's method. You just choose that one. Okay. Actually, you can try an error afterward. Yeah. But this is the one that I want to show for this workshop. Choose sheet, and then for column labels and row labels, tick column labels and tick also row labels. So for row labels, click there, and then you have to click McDonald's samples title, and then drag down to Sunday Caramel. Okay. So, and then for options, okay, okay, since we want to cluster the sample itself, so we choose cluster rows, and then for center and reduce, you just let it be. For truncation, click automatic entropy. This truncation means how many group you want the system to produce. Since we are talking about unsupervised method, so we just choose automatic. We let the system do it based on the characteristic of our sample. Yeah? Yeah. Tak ada. Okay, truncation ada automatic tak? Okay, if you don't have automatic, just untick the truncation. Okay, just let it be. Kita cuba kalau tak okay nanti we will go back. Okay, because mine is 2019 version. You have so you have to choose the entropy. Ada entropy okay, choose entropy. Thank you. Okay. So for missing data, click do not accept missing data because we have already treated this data. We already removed any missing data in the first place. And then for output, click each box. Sama Okay. So for chart as well, lain. Output apa? Klik je semua. Tick everything. Yeah. Descriptive statistics until the variance decomposition. Okay. So for charts, levels, bar chart, dendrogram. For dendrogram, you have to choose vertical. and the rest box shall be plot, including the profile plot. Profile plot is compulsory lah because we want to see the variables. Okay, and then you can click OK. Okay, boleh.
Lain. Ini sekali. Noisy observation.
Tu tak perlu kot. Tu tak perlu.
So ni.
Boleh. Charts. Okay, tak apa. Okay, is it okay? Okay, and then you can click continue. Dapat tak? Tak apa, kalau tak boleh nanti boleh je try balik. Klik saja continue. Continue. Alright. Okay. So this is the result of your cluster analysis. But the description for each part, the important part for cluster analysis is in the tab lah. Another tab that I have prepared for you. So you can see here we have this descriptive statistic, similar with previous result. Proximity metric. Proximity metric is similar like correlation metric in your PCA. Similar. Yeah. So this indicate if someone want to start with cluster analysis, it's also applicable. And then they want to proceed with the PCA as well, also applicable. But most people now looking for PCA because we can find the observation plot and bar plot. And then we have this node statistic. Okay, so this table show the data for the successive node in the dendrogram. Okay, the first node has an index which the number of objects increased by 1, so they will increase the node, and this is happen behind the clustering lah. Okay, the node will be increased until the grouping can be generated. But this one you don't have to report lah. Okay, so this one as well, the node here will be also explained in the form of bar chart like this one. Okay, it's up to you. You want to explain, but usually we don't publish this one because we want to go for the dendrogram. Okay, so this is the dendrogram lah. Okay, so you can see we have 3 groups. Yeah. Okay. This dendrogram, the bottom one is a simplified group or cluster. They just want to show you define 3 groups. Okay, and then we have this class centroid. This class centroid indicate the central value of a nutrient in each group or cluster, in the variable, the middle value. Yeah. And then for this one, distance between the class centroid, this information tells us on the distance value between 2 group or clusters. So we have 3 clusters. They want to find the average value. Okay. What else? The important part. Okay. So from this result, they will tell you the first group you have Big Mac, cheeseburger, McFish, corner pounder with cheese. Yeah. Second group, grilled chicken, hamburger, McChicken, filet o fish. Okay. If you look back at our PCA, these are located nearer. These are being placed out of the group of this beef burger. Yeah. And then those are pommes frites and the apple pie, your dessert are located in the group. Okay. So this is how the groups looks like. Okay. And then from this profile plot is the one the same that I produced in the PowerPoint. Okay. So from here you can see the grouping. Yeah. Okay. The profile plot explains the average nutrient value for each group. Yeah. We need to investigate this result by comparing the profile plot, dendrogram, and biplot from PCA result. Does it contradict the PCA? Yeah. If it is contradict, you can try to redo the cluster analysis by deciding more than 3 groups. For example, 10, 4, or 5. Okay? You can exit to 10, for example. Okay. So this is how the clustering result being produced. Okay. I just want to show you if you want to add more grouping. Okay, you go back to previous IAC that you create, click play here. On the options, which is this truncation, you can choose to click number of classes. This time you want to tell the system, can you create 5 groups? Can you create 10 groups? So this is the one that we call it, we tell the system to produce the group. So if you choose this approach, it will not become unsupervised anymore. It will become supervised because you tell the system to produce the group. Yeah? Compared to you choose the entropy automatic, based on the characteristic of these 5 variables in those 13 menu, they will locate or position the menu into a similar grouping. So this is what a cluster analysis will bring a result. Okay, so you can choose here, for example, I want to have 5 groups. So you're starting from 1 to 5. And then you can click OK, continue. So it will produce another AHC. So you can drag down to see how many group. Okay, it start with first group, one group only. So all sorry. So all sample will become in a group. Sebab tu dia tak ada they are no plot. They put like this one. So if you go to bottom level, if the result the menu are grouped into 2 groups, so you will see here these are the 2 groups. So you can see all your dessert sundae are separated from the burgers and even from fries lah, apple pie, so on and so forth lah. Okay, so if you want to see 3 groups, you will get the similar result previously, the similar one that we carry out. And then if you want to look if they are grouping into 4 groups, okay, so you can see here sundae still in their same group, pommes frites and apple in same group, but grilled chicken and mac chicken in their specific group. Why? Because they are chicken burgers. Okay, the rest are meat burgers except fillet of fish. So you can see why they are grouping together. Okay, so this is how the cluster analysis is being produced. It's not giving you many information, but it can support your PCA result. But it's not compulsory and it's an option. Okay. So I will stop this presentation. We will go to continue with the next part.
The cluster analysis.
Okay, when people do cluster analysis, just to support your PCA. Usually you can see after they carry out the PCA, they give you the result of the cluster just to support. Sometimes people can use the heat map as well. Heat map. But actually they are representing similar result. Yeah. In environmental study, yeah, they did the same approach. Yes. Sometimes you can see nampak cantik sebab banyak sangat result, but actually it's meaningless. I produce similar results lah. But if they want to, macam we call it, we carry out PCA and we want to validate the group. That's why we put cluster. That one will be good. But how they evaluate, they discuss will be a little bit different. Yes. But in some cases, they have a PCA result, but the cluster result are not similar. So in this case, you have to discuss why. Okay. More to make it more interesting in terms of discussion lah. Okay. Yeah.
How do we know the clustering number 3 or 4 or 5? How do we set?
That's I've been telling you. We create PCA, and then we carry out the cluster analysis in automatic version. So if the grouping is similar with the PCA, that will be okay. But if not, you have to do it manually. You have to push the system to create maybe try and error, starting with 1 until 5 or 1 to 10, and you can see the grouping. Are they having a little bit changes in grouping? So from there, you can discuss more why the grouping is a little bit different. Perhaps the investigation in PCA is not enough to support the PCA discussion, so cluster will support that one. Okay, and then you have to take note in this cluster analysis, they cover or they take the whole 5 variables. In PCA, remember the plotting is on F1 and F2 only. So only 75% of the data being used for plotting, observation plot, variable plot, and biplot in PCA. That's why a slight difference in terms of cluster might appear. Okay. Berguna jugalah. Meaning that if you want to plot those compounds or variable which is not being shown in our PCA, it can be covered in the cluster lah. Okay. So cluster done. This one is just how to do it. So that's why I start with automatic entropy this one, and then we proceed to making a few classes lah. Okay. Then we move to the next part, the second last part, which is discriminant analysis in food studies. Okay. So this discriminant analysis is for qualitative purpose. Qualitative, remember, qualitative. You want to make a determination of a sample or a group, so you can use a discriminant analysis. It's not for quantitative. Okay, for example, in halal, we want to know whether they are bovine, porcine, or fish gelatin. So we can use the discriminant analysis. But we don't know how much if there is contamination in the results. So that's why we use discriminant analysis. If you want to know how much the contamination, we will use another method. We call it multiple linear regression. Okay. So that's why we call it discriminant analysis for qualitative purposes. Okay. So discriminant analysis is both an explanatory and predictive technique. Okay. It's also able to predict unknown sample, provided that all your data previously that you have is you generate that, you collect them as a database, save it as a database. But this explanatory and predictive technique are purposely for qualitative purpose, are used for qualitative purpose. Okay. So DA, discriminant analysis, verifies the validated group by cluster analysis. You can make a continuation from their cluster analysis, and then confirm the significant variables that contribute to grouping and authenticate a group of unknown samples. Okay, so from the grouping from your PCA, you try to verify with your cluster, and then from the cluster analysis, you can also validate the clustering using the discriminant analysis. This in the form of, if you want to make it into your thesis continuation, you can adopt this technique. So macam banyaklah you boleh cerita in your data set, from your data set. So this is one of, sometimes people will be asking my advice, how they want to expand in terms of studies of their student. So they carry out some collection of database. So from there we can carry out multivariate data analysis, covering from PCA until to multiple linear regression afterward to complete the whole thesis. Okay. Tapi itulah, tak cantik kalau data sikit tapi nak buat macam-macam. It's good. Tapi sometimes people say macam it's like not so meaningful lah. But if you have a big data, big numbers of replication, it is good if you make a discontinuation lah to support your discussion. Okay. So in this discriminant analysis, if you want to try, why not? Okay. If you want to try, why not? No problem. Actually, it's no harm of training, of using it. Okay. So this discriminant analysis, it shall be divided. The data set shall be divided into training data set and testing data set. Okay. So the first thing that I'm going to discuss is about training data set. So if I want to make a continuation, okay, from your PCA, you have identified the variable having a strong factor loading, remember? So if you have uh, chose you have chosen the variable, the significant one, you can use this data set with the significant variable as your training data set. Okay, so you can see here this training data set is about the palm oil mixed with lard, and then we analyze some of these triacylglycerol, similar data previously. And then at the last column, we tell the system this sample belong to palm oil sample. This sample belong to mixture of lard and palm oil. The last 5 samples contain 100% lard. So if you see here, we tell the system this sample belong to which apa kita kata? Sample lah. So if when we tell the system this way, this one we call it supervised method. Yeah? And now we tell the system, okay, this is my sample, this is palm oil, palm oil, and lard. So we want the system to predict afterward. Okay, so as we tell the system our samples belong to which grouping, so we call it them as a supervised. All right. So from here, by using the training data set from the PCA and CA, we need to confirm the 100% correct classification of the grouping. So itu nak tengok kat mana where we can see this one is from here. And daripada this table, you can see we have, for example, I have lard, 9 lard. So the system, the model from this discriminant analysis able to predict all lard sample belong to lard. So it 100% correct. Those lard and palm oil mixture sample, we collected 27 sample, and the system, the model generated by discriminating DA, able to confirm those mixture are the mixture of lard and palm oil with 100% classification. And then palm oil sample, 9 of them are correctly classified as palm oil. So you can see we get 100% classification. So when you able to achieve this 100% classification, that's indicate your discriminant analysis here able to produce a discriminating model. So this model, together with your training data set, the previous slide, yang ni, training data set, can be used to predict a new sample. Okay?
The DA model and the data set training.
User data set and this DA model can be used to predict a new sample. For example, I have a mixture of palm oil and lard. I analyze, I create this database, and then I carry out this. I try to develop this discriminating model. It able to get 100% correct classification. And then next day, for example, I have a client sending me an oil. They want to know whether this oil belong to lard or palm oil. So I can use this unknown sample. I can predict the lard present or absence in this unknown sample using this model. So this is the application of discriminating model. Okay. So beside of that, beside of having 100% classification, you also need to make sure, okay, the grouping that being produced by discriminant analysis are significantly different. Okay. So from this significantly different, you can see through Weeks lambda test where the Weeks lambda test shall reject the hash null. We will look later in the hands-on. Yeah. So after you comply with this requirement, having 100% correct classification, having a significant different grouping, using feature distance test, and then having a rejection of hash null of Weeks lambda test, that indicate you have developed an effective discriminating model. Okay, so this discriminating model later on will be used to authenticate any sample qualitatively. Okay, so this is the result. Okay, sekejap ya, kita tengok contoh. This is an example. Okay, discriminating model. So you can see here the Fisher distance here. We have three group. Lard, mixture of lard and palm oil, and also palm oil. So you can see here the grouping, the Fisher distance that we have is less than 0.001. The one that we set in the system is p-value 0.01, is very much smaller. So this indicate these three group are significantly different, are very distinct. Dia sangat berbeza grouping ni. So this grouping will become your database afterward. Then support by your Wicks lambda test here. You have to make sure the p-value is less than 0.05, or if you want to go 0.01 for halal authentication, for example. Okay, for us to confirm the grouping are distinct or significantly different, it can be supported with Wicks lambda test. Let's see about the hash null and hash alternative. Hash null here stated that the means vector of three classes are equal, meaning that there is no significant difference between lard palm oil and palm oil grouping. But the hypothesis proposed at least one of the grouping is different from another. Okay, we want to prove this one. So the discriminating model calculate the p-value. So the p-value that we calculated here is less than 0.01. You can see the explanation there. As the computed p-value is lower than 0.05, one shall reject the null hypothesis and accept the alternative hypothesis, hash alternative. So we have to accept this one. At least one of the group are different from another. So that indicate the grouping of lard and palm oil are significantly different.
Can we actually do only one? Shield and do the lambda test.
Yes, can. But as I told you, it's just supporting each result lah. Because this Fisher distance and Wicks lambda test are different tests. So if different tests support each other, that will become a stronger model lah. Okay. Okay, again, this discriminant analysis doesn't apply to everybody's research. But for halal testing, this is compulsory. Halal authentication, or if you don't want to go authentication, you want to know that one particular one particular sample is as it is claimed. So you can use this discriminant analysis. That's why we call it authentication technique. Okay. Beside of that, discriminant analysis as well can show to us that among all those variables that we test, that we use in this discriminant analysis, which ones are the significant ones. Okay, beside of using the PCA, discriminant analysis as well can assist us on that. Okay, so what you can see is you have to make sure the p-value calculated here is less than the one that you have set in the system. Okay, so you can see the p-value in the system that you set is 0.05, less than that. So the calculated p-value here shall be less than 0.05 lah. Those variables having less than 0.05 is considered significant. So you can see here, this is yes, no, yes, no, yes, 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 no, yes. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So out of 13 variables, 7 variables are the most significant to differentiate or to authenticate any oil containing lard or palm oil. So in the case of in food, sometimes people added other, for example, olive oil. Olive oil is very expensive, for example, and then the other virgin olive oil, so on and so forth. But sometimes people want to treat the users, they sell with the highest price, but they mix them with the adulterant, which is palm oil. So you can use this authentication technique using discriminant analysis to support your model. So to achieve that purpose. Okay. Discriminant analysis as well produce grouping results. We call it observation plot. And then this both observation plot can be divided into two. So you can see there are three groups there: lard and palm oil mixture and palm oil. So you can see any mixture lard and palm oil, it will be located in the middle. Yeah? Lard and palm oil grouping, they are really far away between each other. Okay, and then another plot, we call it centroid plot. They only take the average of the grouping here, this one. So they only plot this one, the grouping, this one as well. So they just want to show to you the grouping are really distinct. Okay, so if you receive an unknown sample that people want to check whether they contain lard or palm oil, you can run using your database and then see at this plot if it is false in the middle, so that indicate there is a mixture of lard and palm oil. So that oil is not halal in this case. Okay. Okay. Another results to support this grouping, this plot grouping is using a table. So this one you can predict the sample itself. Okay. So for example, you can see here the one that we prepare, P meaning that containing palm oil, LP here meaning that lard and palm oil prepared oil, and then lard as well is L. Okay, so it will predict you based on the discriminating model. These are the sample, a new sample that we prepared, but we already know the content. We just want to check whether the model have the efficiency to authenticate the known sample. Okay, so they able to predict lah. Palm oil is palm oil, lard palm oil, and then lard is lard lah. Okay, so this is the discriminant analysis. Okay,
So, sorry, for 0.1 or for the table?
Above of 9. Oh, no. We want to see this one, the predicted class. This one, because it is qualitative. Okay, it's qualitative. Sorry buruk lah. Buruk pula saya punya contoh-conteng ni. So it's qualitative result. It's not quantitative, qualitative. Okay, apa lagi yang kita boleh pakai? So we did study sometime. We want to know whether one particular honey, madu, coming from kelulut, coming from apa macam-macam lagi honey kan. So we analyze the honey composition using GC for example, or even their sugar levels using HPLC, and then we carry out the discriminant analysis. So we can authenticate honey sources as well. So this is another application lah. But the one that I show here is for halal because we deal with lard sample. Okay, now we move to hands-on. Okay, so for this hands-on, please open, sekejap ya, saya tengok balik. Yes, ada kan discriminant analysis Okay, sekejap. Okay, please open the number 6 file, discriminant analysis. Alright. Let me show first the explanation on the data. Okay, just open the Excel file first. Okay, so this time we are going to use the large scale of multivariate data analysis. Okay. Oh, dia ulang. Okay, sorry. Okay, so again, this large-scale multivariate data analysis is the data that we use previously in the preliminary requirement, preliminary of MDA, we use the sausages from poultry and beef. So now, from the data, we collect 70 samples, and then we have these variables, total mesophilic aerobic flora, lactic acid bacteria, some variables, volatile compound. Now, we want to use the data to authenticate whether the sausage belong to poultry source or beef source. Okay? Okay, in general, simple saja. Pakai saja PCR test guna DNA. We know that it's poultry or beef. But since the data already there, we can use this chemical data together with microbial data to authenticate poultry and beef sausages lah. Okay, so now open the file number 6, discriminant analysis, and then we will conduct transformation. But I think transformation has been carried out previously. Okay, sekejap ya. Saya buka balik. Okay, so this is the original data. Then it's already transformed. Okay, so this transform data, and then can you see at this part, in the last column, I have added the poultry and beef information. Yeah, because this is a supervised method, we are telling the discriminant analysis test, the algorithm, okay, this sample belong to poultry. These samples, I think from this one, B, coming from beef sausage. Okay, sekejap ya. So how to do the cluster and so the discriminant analysis? Go to XLSTAT. Okay, and then click the XLSTAT icon. Okay, go to modeling, sorry. Go to analyzing data and then click discriminant analysis. Okay, so the discriminant analysis window will appear. Okay, again, sorry. Again, go to analyzing data here and then click discriminant analysis. Okay, so from here, y dependent variables, click there, go to the class title and then drag down to the bottom to the beef information, sorry, beef name. Okay, and then for explanatory variables, okay, click the variables title, which is pH reading, drag to the right for all cheese, and then drag down to the last sample information, value, all cheese value. Okay, and then for qualitative, let it be. Yeah, dependent, remember, dependent variable is qualitative. It's already stated there. So that's why the class is whether poultry or beef. We don't have numbers there. Okay. But for explanatory variable, it shall be quantitative because this is the variables lah. Okay. And then click sheet. And then for variable labels, you have to tick that one. For observation labels, you also have to tick the observation labels box. And then click at the observation label, go to sample name, sample title, drag down to the last sample name. Okay. So up to this part. For options, okay, tolerance, let it 0.001. Click the equality of covariant matrix and click prior probabilities. Significant levels, it's up to you. You want to put 5 or 0.05 or you want to put 1. As myself, I will put 1. Okay. And then for model selection, classes with correction, so on and so forth, just let it be as it is. Okay. For validation, just let it be. We don't want to do validation. When we click this one, we let the system to be, the box to be unticked. The system will validate your data set automatically. The result will be appearing. If you choose validation here, you have to choose which data. But in this case, we just let the system to validate on our own. This one we call it cross validation.
Cross validation if you don't tick.
Meaning that if you want the system to validate your data on its own, we call it cross validation. Okay. And then for prediction, okay, prediction here we untick first, because later on we will try to predict the data using significant variables, for example. But in this workshop, just let it be. For missing data, just click remove the observations. For output, you have to click all boxes. Okay. So for chart as well, you have to click all boxes. And for number of observation, make sure you put up to 100,000, because this is larger data. If you put, for example, 1,000 or 100, they only counting the analysis up to 100 data saja only. Okay, so you have to proceed to increase the number of observation. At least it will not omit some of the data. Okay, and then you can click. Ada any soalan? Ada question? Is it okay? Okay. Ke atau dah putus harapan tengok discriminant analysis? But it's okay. If you have any problem, you just you tell us. Okay, and then click OK. So it will appearing one window. We have qualitative to 70 rows because we have 70 samples. Observation levels as well 70 because 70 sample. Quantitative X because we have 70 samples as well. But for quantitative, we have 18 columns because we have 18 variables. Okay, and then you have to click continue. Okay, so in some cases, your laptop will be a little bit hang. Okay, like myself. But that's it. Okay, this is the challenge of this built-in software. Built-in software, this is the challenge because they have limitation of numbers of data set actually. This happens when we have lots of data. The one that you have here that I show here is not that many, but if you have high numbers of data, I would not go with XLSTAT. We can go to unscrambler, so on and so forth lah. Even now, I go for coding with Python and Anaconda. It is open software, but we need to learn about coding lah. I'm quite lucky because when I did my degree in analytical chemistry, it's compulsory to learn C++. So I've learned a little bit about coding. So that's why we're able to publish using this kind of software if the data is too many and then the software cannot to cover the whole processing lah. Okay, that's why sometimes you find a problem related to hanging of your computer lah. Okay, so this is the result of discriminant analysis. You click this DA sheet here, the one that I have prepared the explanation. Okay. For the DA, not many things are very important. It's not like the PCA, but I will discuss only the significant one. Okay, so starting from the top is about summary statistics. So we have 32 beef sausage and then 38 poultry sausage. Okay, and then it covers this percentage lah in our data. Sorry. Okay, so these are the variables that we have. So we have up to what's 18 18 variables. This is the mean, minimum. Okay, so you can see here, remember when we learned previous topic, we can know the data is already normalized if the mean and standard deviation is 0 and 1 respectively. So what does this mean? Because it's not 0 and 1. Okay, while the data already transformed. This is the reason that I've been telling you. Not all data, even after we carry out the transformation, it will follow normalization. It would not, this data, they don't reach normalization, even though the numbers of variables are more than the McDonald's data. Remember, McDonald's only have 13 menu with 5 variables, but it is able to achieve normalized condition. This is the one that I've been telling you. As long as you transform your data, you are bringing the data from normal, totally not normal, to uh, reaching normal. It's not becoming normal, but reaching normal. So that's why you don't see mean become 0, standard deviation become 1 lah, in this case. So this is the evidence that I've been telling you. If you go to the environmental data that I published previously, it's almost the same. Okay, even though these data are larger. Okay, then we have this correlation metric is still the same with our PCA. Okay, so I don't have to explain this one. Tengok takut terlepas. Okay, and then discriminant analysis, we can see here the mean of each variable in class will be explained here. It's not explained lah, but stated here. Okay, the beef and poultry, the pH, packaging information, so on. Huh? Tak ada. Yeah. Okay. And then we can have this multicollinearity test, a statistic. Okay. So this table identify the variables that are responsible for the multicollinearity between variables. When variable tolerance set less than set tolerance, which is 0.001, that indicate the variable having a multicollinearity lah, meaning that they have a very strong correlation. Okay. But in science, actually, it's not that much lah. We don't look into that one. Okay. Itu just abai. Mostly in this case of social sciences, yes. Okay. But if you see itself, the tolerance we set is 0.01, but the one calculated here is more than that. Yeah. So that indicate no multicollinearity as presence. Okay. Okay, the rest ni, okay, I tak nak tengok yang ni. We want to go to the plotting, how the results are plotting. Okay, we have also box test. So this box test also can provide the information whether we has homoscedasticity or heteroscedasticity information. Okay, so you can see here we have heteroscedasticity condition here. Remember at the preliminary results. Heteroscedasticity meaning that the distribution of variance between the dataset is not equally distributed. Even though at the first place we already transformed the data. Remember, to treat heteroscedasticity, we need to transform the data. We already transformed, it is evidence here, but again, the data is not normal. That's why it also cannot treat the heteroscedasticity. It still occur lah. Okay, but it's okay as long as we transform the data. Okay, now we have the box test Fisher asymptotic approximation. Okay, we want to check the intra-class covariance matrix. Okay, but this one not much important. Okay, you can read this one. Okay, the important part is this one, Fisher distance. We want to check whether the model able to differentiate between beef and poultry sausages. So it is able to differentiate because the beef having number 0, the poultry having number 49 is quite far away. Okay. And then we can support the ability of the model generated in this study using the p-value of Fisher distance. Remember in the PowerPoint, we talk about Fisher distance here. Okay. So the Fisher distance here state about The calculated one is 0.001. Okay. The one that we decided is 0.05, for example. So that's indicate our discriminating model able to differentiate beef and poultry sausages. Yeah. Then we also have the Weeks lambda test. Remember, Weeks lambda test can support our grouping. Okay. You can see the p-value computed is less than 0.01, and then read the explanation here. Since the p-value is lower than significant alpha 0.05, one shall reject the null hypothesis. So accept alternative hypothesis. So the alternative hypothesis says what? At least one of the mean vectors is different from each other. So at least, because we have only two samples, beef and poultry, there is a beef and poultry group are really different from each other. So they are significant lah. Okay, so you can see the definition, the description on this right side here. Okay. Now we want to know, out of 18 variable here, which one are the significant ones? Okay, so this case I have highlighted. I rearrange actually the data based on p-value. So you can see one, berapa ni? 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of 18, 9 of variables are really significant. Now, try to investigate. Kalau you tengok, if you look back at these compounds, this compound generated from the volatile compound detected by GCMS. Okay, while the non-significant variables, you can see starting from rancid until to the spoilage, this is the we call it sensory evaluation. What can we propose from here? Based on sensory evaluation, we cannot differentiate whether those sausage coming from or origin from the poultry or beef. Maksud dia dengan bau sahaja tak boleh pakai. You still need some GCMS to confirm the source lah. Yalah, the best way simple je. You send for PCR test, find the DNA of poultry and beef, you can differentiate the source. But in the case of this data, using your sensory evaluation is not reliable lah. So kalau orang KKM pergi buat audit, dia tak boleh nak cakap ni daripada lembu ke, daripada apa ke, guna dia punya mata atau dia buka bawah hidung semua tak boleh. Memang logically memang tak valid lah kan, but this really support lah this evidence. You know, some sharing lah yang kelakar sikit lah. There is one when I work with Jabatan Kimia Malaysia, we conduct a forensic sample on drugs. Kita ada heroin lah apa semua. We use the one's equipment, we call it XRD, X-ray diffractive macam tu lah XRD kan, diffraction or something, X-ray diffraction. So harga dia dalam 900k at the particular of time. Kita beli 2009. Waktu tu I'm the one who purchase lah. Okay. Previously there is one chemist say, no, when I look at one drugs, I know it's hablo or not, something like that lah. Crystalline or not crystalline. So usually XRD only able to analyze sample or produce a result which is crystalline. If it is not crystalline, we cannot identify what are those compound lah. So what we did during that time, kita kacau dia lah. Kalau macam tu, I letak je lah you kat bilik SRD tu. Tak payah pakai mesin SRD kalau you boleh differentiate using your naked eye whether it's crystalline or not. Okay, so similar like this, if someone claim, if I open the sausage package, I know this is beef or poultry using their sensory. So this is not valid lah. Okay, so this is in the case of application lah, macam mana nak pakai. So you can see that you really need a GCMS volatile compound to confirm the status, the source of the sausage. Then we have this pili trace. This is also similar with the Weeks lambda test, but another approach. Okay, the one that I suggest is Weeks lambda. But since we have pili, we have Potelling lowly, and then we have Roy's greatest root, they are producing a similar result. Okay, to support whether the grouping of beef and poultry are significant or not significant lah.
choose other test. So tak kisah.
Actually, tak kisah. But most of the time people go for Wix Lambda, the most basic one lah. I think in this case, this is might be the limitation lah. The one that I found is Wix Lambda. Perhaps there are some particular study using those PILA other hoteling tests in other studies lah. Okay, in their specific studies. Perhaps I'm the one who didn't find up to now. Okay, uh, but the aim is still the same. Whether you use Wix Lambda, Fisher distance, you use apa hoteling, and then this Roy's greatest root ni, this aim to confirm whether the grouping between beef and poultry are significant or insignificant. Okay, but you can read this one. I just show to you what is the meaning of this information, but we don't report everything in our thesis or paper lah. Okay, so this one similar as well. We have variable factors, correlation. Okay, and then some canonical correlation. We want to see that actually enough with one factor, 97% of data set is covered, is explained, are meaningful, meaning that. Okay. Okay, so let's see the the here. Okay, I think that's all I think on this part.
XLSTAT memang akan bagi results.
Yes. Untitled will give these results lah. Okay. But I'm not so sure about other software. That one we have to look back lah. Okay, and then you have to look on that one. Okay. So this one, okay, this data is based on, you can see here, we have how many data here? 9, 9. So this data actually, I only select 9 most significant data. And then I rerun the DA. I get these results lah. Okay. So usually this is another approach from your first DA here, and then you already find the significant variables from the unidimensional test. Kejap ya, kita tengok dekat sini. Go back to this unidimensional test. This one. And then you choose any p-value less than 0.01 or 0.05. So this 9 variable will be selected for another DA. Sebab they are more significant. Okay, so meaning this, you can propose to KKM, for example. Okay, KKM, instead of 18, choose 9 only. So after this, if we receive one poultry and beef sausages, we just run these 9 variables sajalah. Choose this 9 variable only. So meaning that this data that I have chosen, this one, the 9 variables, is the database now. This one is the original database, 18 variables. But at this time, we didn't select the most significant variable to differentiate between poultry and beef. After we select from the unidimensional results, we bring this into another Excel file and tell them, okay, KKM, if you want to do for monitoring sausage, for example, use this data only as your database. Okay, and then you can carry out another DA lah. Okay, so this is the application for you. Okay, again, in environmental study, what I did, we did the similar thing. Out of 70 variables, water quality, only 25 are the most significant one. So we propose to Department of Environment, so to reduce the uses of so much of money, instead of analyzing 70 data, why not we go for 25? So those 25 variable become our database. Okay, so this is the application. So usually for halal testing, instead of just analyzing, yeah, maybe 25, 20, or 17 amino acids, for example, I just need perhaps 10. Okay, so I can save costs, and then my laboratory can focus on other method for development. Okay, so that is the implication lah. Okay, in reality lah. Okay, so actually we have reached to final part, multiple linear regression, but I would like to request 15-minute break. Yeah. So at 3:30 we try to continue lah. Okay, sebab I tahu we try to continue because we know some of us yang offline akan balik awal sikit, takut jam. So we try to make it mungkin 3 lebih lah, 4. Hmm? Itulah, online. Okay, Assalamualaikum warahmatullahi wabarakatuh. Okay, we will continue with this next session. Sekejap ya. So this session we will continue with multiple linear regression, or we call it MLR, in food studies. So if we recall, discriminant analysis in the previous session is about we can predict qualitatively. This one, if we want to predict quantitatively, so that's why we use multiple linear regression. Actually, if you have any regression technique, you can predict something, or you can quantify something of your sample, the amount of contaminant, for example. Okay. So this is also a continuation. For example, in the case of halal, what we did after we confirm whether one gelatin containing lard, we want to know how much lard content in the adulterated gelatin. We can quantify them using multiple linear regression. Okay. Or if you don't want to go for this one, if you confirm using the discriminant analysis, you can, yeah. Okay. Sorry, Okay, so we are talking about multiple linear regression in this session. So I just repeat. In the previous session, we talked about discriminant analysis. So discriminant analysis aim to predict to predict the sample qualitatively. But this one, multiple linear regression, can be used to predict quantitatively. Kita akan tahu contaminant. We can identify amount of contaminant in your sample. For example, in halal, if you have a gelatin, you know that if you found one gelatin containing containing porcine, so you want to know how much the porcine content, you can quantify them using MLR lah, multiple linear regression. Okay. Okay, so about multiple linear regression as well, it is part of regression analysis. Besides of this MLR, you also can use partial least square regression, principal component regression, and this MLR lah. Okay, so any regression stated in the method that indicate you can quantify one sample or any sample quantitatively. Okay, so in this regression analysis, quantitative values of dependent variable are present. So we will use a quantitative value, a variable. Okay. This step also needs training and testing data set. Okay, that only include the significant variable determined in PCA and confirmed by CNDA, but it's not compulsory lah. Okay, so in the case that you make a continuation from your PCA, CA, and then you try to verify or discriminate using DA, you can use the significant variable in MLR as well. Okay, so but it's not compulsory. Okay, the training data set consists of grouping of sample source with a known value, while the testing data set is comprised of unknown samples. Okay, so we can have a training data set and then also a testing data set. Dia wajib kena buat training data set first and then testing data set. And even though we have a testing data set, the data set that we have that we use in testing data set is shall be an unknown sample lah. Okay. So this MLR must also fulfill the KMO more than 0.5, and then the regression analysis can be executed at alpha 0.05 or 0.01 according to your field of study. Okay. So this MLR also will produce the MLR model. Okay. In the previous session, we talked about discriminant analysis. It will produce the discriminant model. Okay. So for MLR model, we can evaluate the effectiveness or the good of the whether our MLR model is effective for our study or not using a goodness of fit statistic. Okay. So in this goodness of fit statistic, there are lots of indication or indicator that can be used. But the common one, the most common one is we can identify the R square, or we call it determination of coefficient. We also can identify or compare the mean square error, MSE, or root mean square error. Okay, so usually any R square or determination coefficient that near to 1 and lowest MSE and lowest RMSE will be selected lah. And it's also indicate that your model is effective. Okay. So since MLR can be used to predict sample, you have to set up or you have to ensure the MLR model established from your data training data set are really effective. Okay. So after you make the and then you can try to use the testing data set by and then predict the actual value. Okay. So any p-value more than 0.01 will denote that the null hypothesis is accepted. The predicted value are not significantly different. This is from the evaluation of the Z test lah. Okay. So this is the application. So the first one that we need to achieve is this one. Then after getting a MLR model, you can continue with this one just to check whether our model is effective or ineffective lah. Okay. So this is the example. Okay. So again, we will be using lard and palm oil sample. So the first 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. The first 9 sample containing 100% palm oil. The next one here you can see containing a mixture of lard and palm oil. So this is an example. So this is the variable that we are going to use. Okay, one of it is TAG, triacylglycerol. Okay, so it will become independent variables here, this thing. Okay. And then if we look in the previous session of discriminant analysis, this is the column that we tell the system, DA, cluster containing palm oil or lard palm oil. But in MLR, we are not going to use this one. Tak guna, we are not going to use this one, but we will create another column to state how much the adulterant percentage. So you can see here, we can have 100% palm oil. So we put 0 lard. So that's why cluster percentage is 0 lard. And then the bottom one, we have 25% of lard. Sorry, panjang sikit. 50% of lard and 75% of lard. So this column, we call it as dependent variables. But you have to take note, this dependent variable is quantitative. If we compare to this column, the DA column, which will not be used in MNR, It is called dependent variable as well, but qualitative. This one we will not going to use it, tak pakai langsung lah dalam MLR. We are not going in use it in MLR because MLR for quantitative dependent variables. Okay, it's like your calibration curve lah. 0, 25, 50, 75, and then we can calibrate, make a good calibration using your multiple linear regression. Okay, so if you are aware about calibration curve, so you understand this one. Okay, but if you don't understand as well, contact back. We will explain. Okay. Okay. Now we want to develop a MLR model, but we have to ensure the model that we develop are really effective. So by looking at goodness of fit statistic, go to evaluate R square. You can see here R square is 0.9971. As we know that R square near to 1 indicate it is a good model, so it is accepted. Same goes here. We can check on the MSE and RMSE. So the model with lower MSE and RMSE is better lah. So usually if we want to compare different regressions, so for example, we have this MLR, we also have OPLSR, which is not covered in this study. We also can have PCR. When we conduct this regression model, we develop 3 regression model. You can choose the best model by comparing this R square, MSE, and RMSE among these 3 models. So this is an indicator to make a comparison. Okay, beside of that, you can see as well the results here, analysis of covariance, of variance, percentage of clusters. You can see that the given R2, R square, 100% of variability of the dependent variable cluster is explained by the 13 explanatory variables. You can see here. Okay, this can be confirmed by looking at the probability PR more than F statistic. When this probability is less than 0.05 that you have said, that indicate this model is really effective. So you have R square, you also have MSE, RMSE, you also have a probability which is more than determine F statistic, which is less than 0.01. So this indicate your MLR model is very effective. Okay. Beside of that, your MLR model as well will produce a result of equation. So you can get an equation to predict your unknown sample. So this is the equation. 50.6465 minus 0.45 times ICT plus C.24. It's like your calculation, your M apa Y equal to MX plus C lah. Sama macam calibration. Similar like your calibration itu. But this time more variables. From the XLSTAT sendiri. Okay. This equation will be produced by the XLSTAT itself. For any regression model, they will produce the equation. Okay. So the first step is develop a model first using your training data set and then evaluate them. Okay. Okay. For MSc and RMSE, there is no cut-off point, but we can because if you just use MLR, there is no cut-off point, but you can use MSc and RMSE if you want to compare MLR model with other models. Okay, understood? Or for example, you have this one. Sorry, you have this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. You have 13 variable. You create first MLR model. Then MLR will indicate or will choose for you the significant variable out of 13. So you choose the significant variable, you create a second MLR model, and then you compare the MSE and RMSE. So that's one another we call that one application, how to use the RMSE lah. If you just develop one model and only, it's enough to compare R square to and also the probability here, the PF, which is less 0.01 lah. But if you have more models, not one single model, you can compare R square, this probability together with MSE and RMSE. But you have to make sure the lowest RMSE MSE is the better model lah. Okay, faham eh? So kalau ada model lebih daripada satu, boleh compare gunakan MSE dengan RMSE. Kalau ada satu je cukup dengan R square dan juga probability. Okay, mungkin saya kena betulkan sikit lah dekat dia punya PowerPoint tu untuk adding more information. Okay, so similar with discriminant analysis, they will assist you in selecting significant variables. MLR model as well will assist you on getting significant variable as well. Okay, for example, this is another data. I just choose a random one. 1, 2, 3, 4, 5, 6, 7. I have 7 variables. And then the MLR that being developed, the MLR model developed, produce the probability of more than t-test here. So you can see any probability which is highlighted as bold, yeah, which is bold, 0.001. This indicate this variable is the significant one. Okay, unfortunately, out of these 7 variable, only one variable are significant. This is another data set I just want to show. Okay, okay. So in this case, in this study, if we have 7 variables, C18.3, which is a fatty acid here, become the most influential variable in MLR model. Okay, so you can rearrange here the P probability value from the lowest to highest. So you can see C18 is the significant one, followed by C20 until C16. Okay, so this is the ranking variable either we have choose or rearranged. Okay, so in this case as well, what we can say, contoh, example, we have C16.0 as the least significant variable. Kenapa? We have to state lah. C16 is the most abundant palmitic acid, the most abundant fatty acid in plant oil. So that's why it's the least significant in this study lah. Okay, it's commonly found in any plant oil. Okay, ada soalan ke? Tak ada. Okay, so this is the application of which significant variable. Okay, now we have a testing data set. I have highlighted here, testing data set. The previous one is training data set. This one a testing data set. So post developing the MLR model, we want to predict the percentage of adulterant using a testing data set. Okay, so in this testing data set, we prepare another set of sample containing palm oil, mixture of palm oil and lard only. Okay, another set tak pakai, we don't use the similar set of data lah. We analyze more sample, but we already know the percentage. Testing dataset can also be used to predict unknown sample. In this case, we want to evaluate the capability of the MLR model now. Okay. Previous session, we developed the MLR model. And then we confirm R square is good, MSE is low. But now we want to check if we have another set of sample, are they able to predict this percentage accurately? Okay. So from here, we carry out the MLR model, so it will produce a results lah. So from the production of result, you can compile them kita akan tengok. We will look this one at the hands-on. This one is the one that you prepare. 0, 25, 50, 75, 100%. Yang ni. This one. Which is you already know. This one is the predicted one using the MLR model. You get negative 4.99. You prepare 25, you get 21.5%. You prepare 50% LUT in palm oil, you get 45. You prepare 75, you get 72.5. You prepare 100%, you get 99.18. Okay? This one I already average. Nanti kita akan tengok in actual data lah. Okay? So this is actual value which is you prepared. This one is the predicted one. Now we want to know what is it the ML model really effective? We carry out a Z test value. This is before, this is after lah. So you can get this Z test value at individual concentration. Okay, so you can get 0.054 for 0%, 0.219 for 25%, 0.057 at 50%, 0.06 at 75%, and 0.13 at 100%. So from here, you can go to do the Z test, find the hash null, and find the hash alternative. So when the p-value is more, the calculated is more than 0.05, that indicate the hash null is accepted. So it also indicate the predicted one here and actual value prepared are not significantly different. So you prepare 0, you still get 0. So to confirm this one, you do the Z test value. And this is just an additional from your MLR lah. Okay. So this is the application of MLR. Okay, sampai situ ada problem? Ke dah lemau? It's okay. Again, this topic MLR also not apply to everybody. But if you really want to go for finding adulteration or finding percentage of adulterant in food samples using multivariate, you can use this approach. Okay. So we have reached to the hands-on on multiple linear regression. Let's go to open one of the file. Okay. Sekejap ya. Don't save. Okay. So open the file number 7. Multiple linear regression analysis, the last file. Okay. Okay, let's see the data first. Okay, when you already open, let me continue with the PowerPoint slide first. So this time, the data that we are going to use for multiple linear regression is fatty acid composition in palm oil and olive oil mixtures. So as I told you previously, now people are selling olive oil. Sometimes they go up to virgin olive oil. They claim that way, and then they sell in a very high price. But some cases is not authentic, where a mixture of palm oil being added. Palm oil will be mixed with the olive oil, and then they claim it's a virgin oil. Okay, so in certain case, when we cannot authenticate the source of the oil using PCR techniques, so on and so forth, because of some technique having some difficulties or challenges, so kadang-kadang for PCR, for example, PCR test, polymerase chain reaction, any sample containing, we call it inhibitors, they contain inhibitors, so most of oil sample, we can extract the DNA, for example. Kan? So in this case, we have to adopt this technique lah. Pakai FTIR boleh, we can go GCMS, so on and so forth lah. HPLC. So for palm oil and olive oil mixture, for myself, we frequently receive requests from client lah in HUD itself to assist them how to authenticate olive oil lah. So this is one of our suggestion lah, but it's not limited to this technique only. So that's why from the data that we collected, we share to all of you how we conduct the analysis and how we analyze the data. Okay. So for this sample, this data provide information of fatty acid composition of mixture palm oil and olive oil, focusing to authenticate olive oil. Okay, so to do this activity, you need to open file number 7, multiple linear regression. Okay, and then we carry out, I will show you training and testing and training data set, and then we will carry out MLR on testing data set. And then afterward, we will select the significant MLR and then carry out another testing lah. Okay, and just for apa kita panggil exercise lah. Okay, so let me show the Excel file. Excel file. Okay, so this is your data of fatty acid mixed with fatty acid containing in palm oil and olive oil. Okay, so you can see here, this is the column. This is, I have labeled as a training data set. Okay, and then this data already transformed actually, so I don't provide the original data lah, it's transformed. Okay, okay, why I don't provide the original data? Because this data is we collected in our lab. So and it shall go for method validation and verification, so I don't give your original data lah for PNC purpose lah. The previous one data is the data that we collect from the open source, so that's why I share to all of you. So this data will show you the transform one. So you can see we have palm oil and olive oil from here according to percentage of adulterate. So if we put here palm oil and olive oil 0 to 100, meaning that 0 palm oil, 100 olive oil lah. Okay, so this is 100% olive oil. This one 25% palm oil, 75% olive oil. Okay, 50% palm oil, 50% olive oil, 75% palm oil, 100% palm oil. So in this case, we denote that palm oil is the adulterant. So that's why we put here at the last column. 0%, 25%, 50%, 75%, 100%. Because we want to investigate the adulterant. If I put the olive oil, that would be make an inverse. Okay? But actually it's really inverse. You can just want to know how much olive oil in palm oil, for example. Okay, it's almost similar. This column is not going to be used because this is resemblance of discriminant analysis approach. Remember, this MLR for quantitative, so that's why this is the meaningful column. Okay, since it is not for qualitative, so this column is not meaningful lah in MLR. Okay, so this is the training data set. Again, at the bottom one, we have testing data set. Okay, so this testing data set, we analyze replicate with a known concentration of palm oil in olive oil. So I have prepared this one, how much the adulterate, 0, 25, 550, 75 and 100. Okay, but now I want to confirm, if I prepare 0%, can we get 0% palm oil? That's why I put a we call it one question mark there. Okay, we want to know the model developed from the training data set are really effective or not. Okay, and then the last table is the unknown sample. What if after I develop this method and then client from industries coming to in lab, for example, they asking us, can you confirm is it how much palm oil in this olive oil? So that's why we label as unknown, but we already analyzed the fatty acids lah. Okay. Yeah. Mm-mm. Transform variable from raw data, the one that we learned this morning, the standardized. This is the same one. This is the transformation. Okay, I won't do it, but I will just make some recall what we shall click. So if you remember, you open up this XLSTAT, go to preparing data, and then we go for variable transformation. Remember this one this morning? The first section, this transformation, this is the transformation from the raw data. Okay, but it's okay since this is a recorded version. So after I upload in the YouTube, I will provide into our Google Calendar as well in our WhatsApp group. So you can watch again if you want to know how to transform the data lah. Okay, so this is carried out this morning actually. Okay, so this is but the data we have here is PNC. So the one that I share here is the transform one. Okay, and then you need to carry out the multiple linear regression. The result is already here, already carried out for you, but we want to do but I will show to you how to do the MLR lah. Okay, so ada soalan apa-apa before we start? Any question before we move? Ada? Okay, kalau tak ada, I just proceed. Okay, to do the MLR, we go to modeling data and then click linear regression, the number 2. Okay, so it will be appearing one features here. Okay, again, to do MLR, go to modeling data and then click linear regression. Okay, so now we have to click the Y, which is dependent variable. Remember, the last column is the dependent variable, quantitative one. Okay, so it's proven here. You can see here, Y dependent variables, quantitative. So the system already told us it's quantitative. Okay, if you choose this cluster column, this one, this column, this is wrong lah because it's not quantitative. So for now, we have to go to palm oil adulterant and then click down to the last percentage of palm oil. Okay, again, click quantitative one here, go to the title of palm oil adulterant and then drag down to the last percentage of adulterant, which is 100% here. Okay, then we have this one, X explanatory variables. You have to tick quantitative box. Yang ni quantitative box. Tick the quantitative box. Go to the title of C14.0, C14.0, drag down to C18.3, and then drag down to the bottom. Sini je, sampai sini je. We go for training data set only. Okay, so again, for this X, go to C14.0, drag to the right to the C18.3, and then drag down to last data lah. Okay, then you have to click sheet here, tick variable labels. For observations label box, you need to tick as well, and this time you have to click this one to choose the sample name. So go to palm olive oil title and then drag down to the 100. Okay, that one for observations label lah. Okay, and then for options, for model part, the model tab here, just let it be. The fixed intercept, interaction, let it be. But confidence interval, you have to click 99 or you want to choose 95. It's up to you. Remember, 99 means you allow 1% error or 0.01. 95% confidence level indicate you want 95% confidence level, you allow 5% error lah. Sekejap I sambung wire kejap. Sekejap ya. Alright. Alright. Now for covariance, let it be, biar saja. Okay. For validation, let it be as well, biarkan saja. For prediction, also let it be, biarkan saja. Yang ni kita akan pakai kalau nak try lah on unknown data. And then for missing data, just click do not accept missing data. Sorry. For output, on general tab, click all boxes. For contrast, let it be. For test assumption, click normality test. This one tak ada apa pun. Nak klik pun boleh, tak nak klik pun tak apa. If you want to click it, just click it. Not clicking, also no problem. Okay. And then for charts, click all boxes. Okay. Is it okay, everyone? You want to move? Okay. I hope everyone is okay. This one is quite simple for MLR ni. Dia macam our linear regression je. Okay. And then click OK. So as usual, there is a small window appear. So you have 25 rows, and then you have 25 sample. You have 7 column, indicate you have 7 variables lah. Okay, and then click continue. So you will get linear regression. Yeah. Okay. Now, first thing first, we want to know how good our model. So the model can be evaluated using R square. So the R square that we receive is 0.999989 lah. So very good. Okay. We also have MSE and RMSE. So again, this one, if we want to compare with other models, so in this case, we cannot put any decision, but as low as it's low, but it doesn't have any cut-off point lah. Okay. Another one, remember there is an analysis of variance. We have to make sure the P probability is less than 0.01 in my case. If you choose 95 confidence level, it should be 0.05 lah. Sorry, 0.05. So in my case, I choose the setup is 0.01, less than 0.01. The one that I receive is very much smaller. So indicate your model is very good, even though using a 7 variables. Okay. Then equation. So this is the equation produced. If we want to predict afterward with a known compound, a known sample, olive oil, we can use this calculation lah. So if you want to make a report in your thesis, at least you can produce. So this is a calculation you can type, but simplified it. Okay, macam ni you tengok panjang sangat 45.523, banyak sangat dia punya decimal point. So you make it up to 2 decimal point, it will be easier. Now, because when you talk about regression, definitely it will produce a formula or equation for all of you. Okay. Now we want to know which variable are the significant ones in our study. So you can see at the standardized coefficient here. Okay. And then look at the probability column, PR. Okay. So you can see here those that having value less than 0.01. In my case, kalau you pakai 0.05, you have to check lah, okay, is considered significant. So only one is less than 0.01. Yang lain ni semua tinggi, the rest. So out of 7, 18, C183 is the most meaningful or determinant, become a determinant in this, determinant variable in this model lah. The rest also functioning, but they are not really as significant as C3 lah. Okay. Beside of this table, you also can explain the significant variable using this palm oil standardized coefficient graph. Okay. Any variable that the graph is further away from the center, which is the 0, indicate they are the significant one. So you can see here C183 is the number 1. This one number 2. This one CA14 and C18 almost the similar one. Tapi kita boleh tengok dekat sini lah, dekat table. C14, C18 mana lagi tinggi? C18. Okay, C18 tu sorry, C18 tu 0.5. C14 0 is 0.2. So this one is number 3. So the rest are C18 1, I think the least significant, is it correct? C16, sorry, C16. Oh ni. Ni yang paling kecil because it's too near to the center. So this is another way to show like macam cantik sikit lah. It's very more beautiful in explaining the results. Simplified lah. But from here, I think in order for us to type in written form, using this table will be meaningful. Okay, but you can use this diagram as the display, but in explanation, you refer to this table. Okay, it will be easier using table lah. Okay, and then we have the prediction, so on and so forth. Okay, so this one is the result lah. Okay, apa lagi nak tengok? Ini tak ada apa lah. Okay, now remember at the original data set, we have another data set, we call it testing. Okay, now in this testing, data set, we have prepared a known concentration of palm oil. Does our data able to what you call that one? Determine the percentage of adulterant, the palm oil? Okay, so go back to your linear regression one. We call it tab here, sheet. Okay, pergi balik dekat you punya tadi, linear regression sheet. And then go click play. So it will be appearing the similar setting in the previous analysis. So let it be everything, let it be. Go to prediction now. Go to prediction tab. Linear regression one. The linear regression tab that I have prepared is from my previous, I think, 4 or 5 months before. The one that we are going to use is linear regression one. Okay, the one that we have just prepared. Go click the play button and then go to the prediction. Okay, play button tu kat mana? Takut terlepas. Go to this one, linear regression one. This one, click play button. So this one is an easier route lah. Okay, it will go back to the setting of our MLR just now. So you don't have to reselect those data, but now we want to add the testing data set. Okay, so you go to prediction tab, click here. Okay, click here. Then the explanatory variables on the quantitative box, click the quantitative box, and then click the part that one. Okay, and then go to your testing data set. Okay, this time choose the first cell below the title. This one, not the C14, below the title, drag to C18 cell below C18.3, and then drag down to the testing data set only. That's the setting. This is just the XLSTAT setting. If you choose C14 until C18, it's not crash lah. Dia macam it will not continue the analysis. So this is the trick lah. The problem with when we conduct this the software, different software having different trick. Yeah. Those days there's sometime when we after conduct this workshop, people will be coming back. I cannot click here, click there. Okay, perhaps because of that. Okay. So I have to inform. So again, for the prediction, you have to tick prediction box and then tick the quantitative box as well. And then to choose the variable, click there and then choose the data underneath of the cell C14.0. Don't click C14.0 lah. Okay. This one for prediction only. Go drag to the right side at C18.3, below of C18.3, the cell below C18.3, and then drag down to the last sample, C18.3. And go to testing dataset. And then for observation labels, okay, this one, same goes here. Go to the final, go to the first name of palm olive oil. Not the title, the sample itself. 0, 100, okay, and then 100, 0. And then the rest is similar setting. You don't have to click, yeah.
So we have the labels, right? That's that. Very good.
And then you click OK. And then you can see this is a small window. So you have similar information, but now with additional information. Prediction, you have 15 rows, meaning that you have 15 samples. Column still the same, 7, because you have 7, still the same 7 variables. Okay. And then click continue. So it will produce linear regression 2. Result, okay, nak tengok dekat mana? Go to the one of the bottom one. Is it this one? Yeah. Okay, this one. No. Sekejap. Sekejap ya. Saya tunjuk dulu. Tak ada. Regression. Diagnosis. Sekejap ya. Nampak tak? Bawah lagi Yes, this one. Thank you. Baru nampak. Itulah kadang-kadang kita belajar dengan orang pula. Okay. So you can see here, this is the prediction lah. Okay. Saya pula yang tak perasan. So, we prepare, okay, kita copy balik. I try copy yang ni. Just nak tunjuk lah. Yeah, I try to copy this one. So, I paste this part. Oh, sorry. Okay tak? Tak nampak? Tak apa. Sekejap saya tengok balik. Okay. So, we prepare 0. We get this one lah. Negative lah. Okay. We prepare 25. We get 24. We prepare 50. We get 50, 48, 49. Quite good lah. 75, we get 75%. We prepare 100, yes, we get 101. So this is indicate that your result is quite effective and you can support with the Z test. Okay, macam dalam PowerPoint tu lah. This also indicate your R square having, your MLR model have R square near to 1. You have low RMSE. Your probability is less than 0.01. So that's indicate the model is quite good and it able to predict this known concentration of palm oil adulterant. Okay. So now kita ada satu lagi data, this one. Remember the last data? What if our client send us unknown sample? But this time we don't know at all. Tak tahu pun berapa banyak the adulterant lah. So we can follow the similar approach. Okay. Go to linear regression to fit. Go to the top. Again, click the play button. This time we want to use the training data set together with the unknown. So nak masuk dekat mana kalau if our client send a sample. Okay, so click the play button. So it will appearing a similar window, but at the prediction tab here, okay, prediction tab ni, you have to choose the new data set lah. Okay, so this one prediction, you have to tick the box. Quantitative ticks the box as well. But for this, the data, click here, go to the unknown sample, similar approach, click 5.23, the data below the C14.0, drag to C18.3, drag to bottom one. And then for observation labels, click the same one, and then go to unknown sample 1, UNK1, click, drag down to the UNK15. UNK mean unknown, 115. Okay, and then you can click OK. Okay, so actually you can get a similar results lah. Okay, so the same way to review is still this one kan predicted one lah sini Okay, so this is the predicted information lah if you get an unknown sample. Okay, boleh? Tak boleh? Okay, so sampai situ ada soalan tak? Boleh? Tak ada Boleh? Okay. Apa kita tunggu yang offline ada masalah sikit. Kita bagi relax sikit. Kita pun baru 4:23 walaupun ada orang boleh balik awal. Okay, sekejap Ya ke? Tak apa, kejap kita tengok. Okay. Sebelum tu dah 4:23. So let me end the session first, boleh? Okay. Okay. So for this workshop, these are the references that I recommend everyone if they want to see how I wrote lah. Okay. Most of it is not I'm not the what you call it the main data set owner. Usually people coming to me and asking me to help lah. So this is the first one that I carry out. Yeah. This one I received data from Jakim Laboratory, okay, for halal testing. So we conduct this one. From UPM, some of the UPM halal products, they also request me to assist them on authenticating lard in fish feed. Okay, some of the data being showed. Yeah. And then we also carry out another, we call it food forensics. This case is quite tricky because I have to use forensic food because at that particular of time when I send a paper related to halal for international journal, they claim that that is for the dia kata minorities. So to avoid this discrimination, I change instead of halal authentication, I use food forensics lah. Sebenarnya maksud dia sama je. Okay. And then we also carry out discrimination of honey. This one also with UPM, halal UPM. Okay. And then for those yang nak tengok method validation for halal testing laboratories, this one is I myself as the main author. So this one we bring to Turkey to SMIC, I think, for one of the methods lah, to share with them how we develop, validate and verify method. In this paper as well, we carry out multivariate data analysis rules lah. Okay. The latest one I publish chemometric based evaluation. This case I use papaya pill seed to investigate the antibacterial activity and its ability to kill bacteria lah. Together with that, we combine with fatty acid composition and to find the linkage between how the compound inhibit the growth of bacteria. So this is one of uh, one of the papers that been published lah. Okay. And then again, before I end this session, I would like to say thank you everyone. So we in Nahat would like to say we are really grateful having you on board and also online. So these are Inhat is conducting monthly workshop. So we have various workshop lah. Yang ni I provide some of the workshop that being carried out. GCMS bio for authentication and chemometrics combined in GCMS results will be conducted their workshop next month. But it's a little bit pricey because it is face to face. Because we will teaching the conduct the workshop, participant will need to inject the sample and do the preparation, inject sample, and then this is 2 days workshop. We also carry out method validation and verification. This one being carried out like the Institute Kimia Malaysia. So those lab testing would like to establish their method, and for those who use doing the research in developing new method, this might be beneficial to all of you as well. We also carry out authentication for halal using FTIR for oil sample. This one also combined with chemometrics lah. Okay, so you can visit our website as well. From there, we will and Facebook, we will inform you about our latest workshop that will be conducted along this or throughout the year lah. Okay, so I think that's all from me. Thank you again for joining this workshop. Kalau ada masalah boleh tanya. Okay, ada soalan atau tak sebelum kita tamatkan? Yap. Mm-mm. Mm-mm. 14 days sahaja. After that kena beli ataupun boleh buat cara lain. Kalau nak tahu boleh PM lah. So since this video I will upload to YouTube, saya tak disclose sangat lah. Ataupun boleh tanya kawan-kawan yang pernah belilah. Okay, again, XLSTAT is not the only software yang ada. You boleh pakai Unscrambler, you boleh pakai Minitab. As far as I know, kalau if you are from UM, for example, they purchase JMP. So JMP being subscribed by UM, so you can use this software as well. Okay, and then for your information, sometimes when your data is too many, now we go for Python and R, our Anaconda, where we conduct a coding lah. Okay, so yang ni I dah buat untuk publication the latest one with COVID test, COVID case in Malaysia. So we try to predict with the Python punya software lah. Okay, so I think that's all. Since again, this is after sales announcement. Siapa yang ada masalah, or you have any problem, you can contact me again. InsyaAllah still free, no payment. Tapi kalau I get involved with the collaboration, I'm also suggesting if you can invite me as part of the apa kita panggil authors lah. Yeah, again. Tu dah ada kat situ. Zero. Okay, dalam WhatsApp group pun ada my phone number, email pun ada. So insyaAllah kalau you having problem, you have your data and you want me to assist insyaAllah. But saya nak minta tu lah, jasa baik untuk masuk sekali dalam paper tu lah. But if I join the paper, saya akan kejar. So after you carry out your data analysis, okay, in my approach is kita akan buat Google Meet. I will coach you how to do it. So that kalau viva ke, ada paper punya correction ke, you know how to answer lah. But afterward, you have to send the paper to me after the correction, after you make the data analysis, you evaluate, and then I will improve the evaluation lah. Okay. Itu saja daripada saya. I will say thank you to Inhad as well for providing this opportunity. Walaupun saya yang conduct sendiri, tapi alhamdulillah I will receive support from the bosses. Okay. Again, yang ni saya nak cakap terima kasih sebab all of this while when you join Inhad workshop, you support our lab. We have lots of equipment which is broken and going to be expired. We able to use this money collected from all of you so that we can repair the equipment lah. So this is how I define sustainability in HUD lah. Yeah. For other approach, perhaps sustainability coming from other means, but from in HUD lab, this is the option that we have lah. Okay. So thank you again everyone. Nanti kalau apa-apa kita jumpa lagi. Okay. This video will be uploaded to YouTube and I will provide the link. Thank you again. Okay, Sis Arifah, go back to you. Okay, itu sajalah. Assalamualaikum warahmatullahi wabarakatuh.
I just got my XLSTAT license.
Baru dapat? Okay.
Uninstall and